Hello, and welcome to this course, Continuous Integration and Continuous Delivery Using Jenkins Pipelines. Recently, DevOps practices like continuous integration, continuous delivery, and continuous deployment have become some of the most popular application development practices. As developers integrate bug fixes, new feature development, or innovative functionality in their source code repositories, there is need for automating these processes. Jenkins is a popular continuous integration tool that enables you to verify the integration process with an automated build and automated test execution. As a result of this automation, Jenkins provides valuable and quick feedback about the state and quality of your source code. Jenkins is an open-source automation tool written in Java with plugins built for continuous integration purposes. Jenkins can be configured to trigger a build for every change made in the source code repository, like Git, Subversion, VSTS, etc. Jenkins allows the teams to focus on their work by automating the build, artifact management, and deployment processes. Jenkins' core functionality and flexibility allow it to fit in a variety of environments and can help streamline the development process for all stakeholders involved. In this course, you will learn about Jenkins and its various components and services. You will get an in-depth look at how you can use Jenkins to manage your build and automation jobs. Knowledge and experience on Jenkins are highly sought after by startups and large enterprises alike. The demand for these skills has been steadily increasing over the last few years. We hope you enjoy this course and the information we are going to share with you. So let's get started. Here is an overview of what we are going to cover in this course. We will begin with an introduction of Jenkins, where you will learn about the basic concepts and features of Jenkins. You will also get familiar with some key concepts and terminology related to Jenkins. After you have gone through the theory, we will dive deep and understand the installation and configuration process for Jenkins. Then, in the next module, we will configure some build jobs within Jenkins. Last but not least, you will learn about managing pipelines and the scalable master-slave architecture which Jenkins supports. In light of this being a course overview, what can you expect to take away from this course? Well, by the end of this course, you will be equipped with enough information about Jenkins. You will learn about the key features, terms, and components associated with Jenkins. You will get in-depth knowledge about installation and configuration for Jenkins. Since this course provides detailed demos of installation and configuration of Jenkins, it will equip you well for future use of this technology. Jenkins is a very robust and widely popular framework for implementing automated continuous integration, continuous delivery, and DevOps pipelines. Implementing these practices using Jenkins will bring tremendous benefits to your projects. Jenkins is an extremely flexible and powerful solution used for continuous integration of projects. At tetratutorials.com, we focus on in-demand skills and real-world education. Gaining this practical knowledge and experience with Jenkins will be very valuable for your career, and it will be a right step towards improving your work or your project or career prospects. The more in-depth knowledge you have about Jenkins, the more marketable you will be. As you have already seen in the course overview, this course aims to provide you with an in-depth look at an essential DevOps framework called Jenkins. We have tried to provide you with some real-world scenarios and use cases which you will be able to leverage immediately in your projects. The introductory modules help you understand the Jenkins platform better. After the introductory modules, we will take a deep dive into the installation, configuration, and operation of the Jenkins platform. The information in the upcoming modules will give you a deep understanding of how to build and deploy your code automatically using Jenkins. See you in the next module, where we will introduce you to Jenkins and we will learn more about the Jenkins platform and its features. Hello, and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In this module, we will introduce you to the core DevOps concepts like continuous integration and continuous delivery with Jenkins. You will also get familiar with Jenkins features, its advantages, and explore the Jenkins architecture. Before we dive into a discussion about Jenkins, let's first understand some key terms. The practice of automatically building your code periodically is called continuous integration. The resulting binaries after building the code can also be deployed automatically to the target environment. This practice is called continuous delivery or continuous deployment. To paraphrase, Wikipedia defines continuous integration, CI, as the practice in software engineering of merging all developer working copies to a shared mainline several times a day. And continuous delivery as a software engineering approach in which teams produce software in short cycles, ensuring that software can be reliably released at any time. It aims at building, testing, and releasing software faster and more frequently. Now let's see how it works in practice. During the course of a regular software development lifecycle, one or more team members check in their code regularly into a source version control system, or repository, like Git, Subversion, etc. The CI server then fetches these fresh changes and integrates them. It then runs the build processes and produces a bundle of software build artifacts. These artifacts are then versioned and stored in a build repository. The CI server then runs several automated tests like unit tests, integration tests, etc., to validate the build artifacts. CI service may also send notifications to the team about the success or failure of this CI run. The CI server can run this entire process many times a day based on several triggers. For instance, upon every check-in of new source code from any developer, or on a periodic basis. Why are these DevOps practices becoming so popular these days? And what benefits do they provide? One of the key driving forces behind CI and CD is to detect problems or bugs as early as possible in the development lifecycle. If we only build and integrate our code right before a QA cycle or before a big release, we are running a high risk of last-minute failures in our integrated code base. By integrating all the changes coming in from various team members and building the integrated source on a frequent basis, these risks are minimized. Effective application of CI and CD practices can provide a greater confidence to the team in building their software products. As new changes and features are introduced into the source stream, the team can confidently accommodate these changes. Since the entire codebase is integrated, built, tested, and deployed with sufficient frequency, the potential bugs and errors are caught earlier on in the cycle. The faster feedback loop inevitably results in better quality software. Since the builds are automated and the source is integrated and continuously built and deployed, there is little to no delay in producing a set of artifacts and making them available to the customers. All builds are stamped with a systematic build number. This results in a fully tractable build and deployment process. It gives us the ability to take any particular version of the software and trace back the exact commits which were made to produce that build or version of the system. This is incredibly helpful while trying to troubleshoot issues for support purposes. Over time, your CI and CD processes collect valuable information about your source code. This information, or metrics, can be tracked and analyzed to give us a broader perspective of your code and team. You can answer questions like, Is your code coverage increasing over time? Are your builds taking longer and longer to complete? Do you have more or less build failures per day? This is tremendously useful for the development team and organization as a whole. If there is a noticeable degradation in quality, corrective measures may be taken earlier on in the development cycle. Since most of the build, integration, and deployment processes are automated with the help of CI and CD, teams can ship the products faster and more consistently. Some organizations have taken automation to the extreme and they ship their code several times a day. All these benefits result in a lower cost of development and ultimately have a huge impact on the overall bottom line of the company. There are various products, frameworks, and tools available which can help us implement CI and CD pipelines in our environments. Here are only a few of the most popular ones. Some are open source and absolutely free, with huge community support behind them, whereas others are commercial proprietary products produced by some very reputable companies. Some options let you host a CI server in your network infrastructure, and other products are completely hosted in the cloud. We can evaluate any of these options based on the business and technical requirements of our project, and of course their suitability to our environment. In this course, we will obviously focus our attention to Jenkins. During the software development process, the software team needs to perform several tasks, such as committing the code frequently, testing, staging builds, and getting the code from the development into the production environment. Performing all these tasks manually within the development process consumes a lot of time and focus. In addition, running regression test cases is a very time-consuming job if it is manual testing. Apart from the fact that manual processes are more tedious and inefficient, manual integration also increases the likelihood of mistakes, rate of bugs, configuration issues, and customer frustration. So how can you ensure a high-quality product with minimal delays and mistakes? Let's explore! The Devops processes enable you to overcome the limitations of the manual approach. As soon as new code is checked into the source code repository, it can be automatically built and tests can be run to validate the new code. This process not only validates the new code itself, but also ensures that it works in an integrated manner with the rest of the code base. Once the code is validated, we can go ahead and deploy the new build onto the dev, QA, and production deployments. In some companies, this process is repeated thousands of times a day, and customers get new software versions within moments of the new code getting pushed to the source code repository. Introducing continuous integration, continuous delivery, continuous deployment, and other DevOps practices in an organization radically changes the whole development process. It enables and triggers a series of incremental process improvements, going from a simple scheduled automated build right through to continuous delivery into production. Processes that were used before the implementation of DevOps practices had many flaws. As a result, not only the software delivery was slow, but the quality of software was also not up to the mark. Developers also had a tough time in locating and fixing bugs. Therefore, implementing a DevOps culture and infrastructure can help you in streamlining the development process right through deployment, detecting and fixing bugs faster, providing a useful project dashboard for both developers and non-developers, and ultimately in helping the teams deliver more to the end user. Jenkins is one of the most popular tools for implementing continuous integration, continuous delivery, and continuous deployment pipelines for any platform or technology. It is an open source automation tool written in Java with plugins built for DevOps purposes. Jenkins can trigger a build for every change made in the source code repository, For example, a Git repository. Once the code is built, Jenkins deploys it on a test server for testing. The concerned teams are constantly notified about the build and test. Jenkins deploys the build application on the production server. Thus, Jenkins helps in cutting down costs by enabling teams to automate their build and release process. To enhance its power and usability, Jenkins supports thousands of plugins. There is a huge and active community behind Jenkins, and they are constantly contributing to and updating the plugin ecosystem, which makes the Jenkins platform even more powerful and flexible every day. In an improbable scenario where you cannot find a suitable plugin for your project or situation, you yourself can extend Jenkins by developing additional plugins. That is the advantage of using an open source platform, which has a strong and generous community behind it. So we saw Jenkins has tremendous advantages, like it is a very low-cost open source solution, it has an active community behind it, and it has a vast ecosystem of plugins. Apart from that, the key tangible benefits of Jenkins are that it increases the developer productivity and brings greater agility to the development process by automating the mundane but important tasks. To summarize, Jenkins is an open source platform that can handle any kind of build, continuous integration, continuous delivery, or DevOps task. You can integrate Jenkins with a number of testing and deployment technologies. Jenkins is a powerful platform that allows continuous integration and continuous delivery of projects, regardless of the platform you are working on. Jenkins can be extended by additional plugins. It is a tried and tested platform which is widely used in the industry, from small startups to very large corporations. Let's get technical now and answer some key questions about Jenkins. How does Jenkins work? What are the key terms and concepts related to Jenkins architecture? Well, there is no surprise that Jenkins implements different DevOps steps with the help of plugins. Plugins allow the integration of various DevOps stages within the Jenkins framework. If you want to integrate a particular tool, stack, framework, or platform, you need to install the Jenkins plugins for that particular tool or framework so that Jenkins can work with it seamlessly. For instance, you may want to use Git via a Git plugin, Maven 2 via a Maven plugin, and some cloud-related frameworks using AWS or Azure-specific plugins. Now, let us explore the architecture of Jenkins and see what are its core components. Generally speaking, Jenkins uses the master-slave architecture to manage distributed builds. In this architecture, master and slave communicate through TCP/IP protocol. The main Jenkins server in this distributed architecture is the master server. The master's job is to pull the SCM repositories, which could be anything from Git to Subversion to CVS, etc. Schedule build jobs. Dispatch builds to the slaves for the actual execution. Monitor the slaves, possibly taking them online and offline as required. Record and present the build results. So primarily, the master's job is to orchestrate the builds and jobs across the whole cluster. That being said, a master's instance of Jenkins can also execute build jobs directly, whereas a slave Jenkins instance is a Java executable that runs on a remote machine. The slave Jenkins instances accept requests from the Jenkins master instance and execute the job and report back to the status of the master. Slaves can run on a variety of operating systems. You can configure a project to always run on a particular slave machine or on a certain type of slave machine, or simply let Jenkins pick the next available slave. For example, in this diagram, you can see that Jenkins architecture consists of a Jenkins master, which is managing 2 Jenkins slaves. The Jenkins master distributes the workload to the slaves, which accepts the requests given by the master. Additional slave nodes can be added to this architecture as the load on the system grows. Let's end this module with a quick recap. You now understand that DevOps practices like continuous integration, continuous delivery, and continuous deployment help in increasing the productivity and streamlining the software development process. DevOps practices reduce the overall risk of the project by discovering errors early in the cycle and thus increases the overall quality of the product. Jenkins is an excellent open source automation tool written in Java with plugin support. It is a tried and tested platform for implementing our DevOps pipelines and components. In the next module, we will walk through the process of installing and configuring Jenkins. Catch you in the next lecture! Hello, and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we got familiar with some core DevOps concepts. We also learned about what Jenkins is and what advantages it provides. In this module, we will get our hands dirty and get started with Jenkins. We will install the prerequisites for Jenkins and then continue on with installation and configuration of Jenkins and see it in action. We will also configure the essential settings and some add-ons to run our Jenkins service. Finally, we will walk through the features which Jenkins provides. Amongst these features is also the Build Pipeline view. We will review this pipeline view with the help of Build Pipeline add-in. We will learn about the purpose and benefits of this pipeline view. So let's get started. First of all, let's review our environment which we are going to use to install our Jenkins instance. Here we have logged into our workstation where we will install our Jenkins instance. Let's review it now. This physical machine is a Windows machine. It has Oracle VirtualBox installed on it for running virtual machines. We will use a Linux virtual machine to install and run our Jenkins server. Installing, configuring, and running VirtualBox and virtual machines is a very straightforward process. But in case you need any help, please refer to the URL for documentation. In this particular instance, the Linux flavor we are using is CentOS version 7. In order to make our journey more comfortable, we will make use of SSH sessions to connect and run commands on our Linux virtual machine. For this, we will use a free and easy-to-use SSH tool called Putty. If you are working on a Linux or Mac OS machine with an alternate SSH tool, you can use that instead. The main objective is that you should be able to log into your Linux instance via SSH. We have already downloaded and installed Putty. Once again, the process of installation is pretty straightforward. You can simply Google for Putty and follow the instructions to install it. In order to configure our SSH session via Putty, all you need to input is the IP address of our Linux machine. And to get your IP address for our Linux instance, you need to execute IPA on your Linux instance. And here is our IP address, 192.168.0.101. You need to input it down here in the Putty connection configuration dialog. Please note the default port for SSH is 22. Once it is configured like so, we will click on Open to establish our SSH connection. Now, since we have connected to this machine for the first time, SSH is warning us. Let's click Yes on this dialog and proceed further. Here we will log in as the root user. Since this is just an academic exercise, we are using root for convenience purposes. But it is recommended that for real-world cases, you use a user with appropriate permissions and avoid logging in as the root user. We will use the root and the password that we configured during the installation of our Linux instance. Okay, now we are logged on to our Linux system. Now let's start with the installation process for Jenkins. Next, in order to install Jenkins on your Linux instance, you will need to ensure that Java has been installed on your Linux instance, because this is a necessary prerequisite for installing and running Jenkins. We will visit this step shortly. The most comfortable way to install Jenkins is to go to the official website, wiki.jenkinsci.org. Here on the installation page, you can click on the link for your particular OS to get detailed instructions to proceed further. We are using CentOS, which is compatible with the Red Hat distribution of Linux. So we will click on that link. And here we can see all the necessary steps that we need to execute to install our Jenkins service. Here is an additional important note about CentOS distribution and Java. Some versions of CentOS have their own version of Java installed. In order to avoid any compatibility issues, Jenkins Wiki suggests that we check whether we have the correct version of Java installed or not. Let's check and verify now. We will execute this command to verify the version of Java, java-version. Okay, as you can see, we don't have any Java version installed on this machine. The minimum version of Java required for Jenkins is Java 7. Jenkins Wiki conveniently also provides the necessary command to install Java. Let's execute this now. Yum install java-1.7.0-openjdk. Let's wait for the installation to finish. After the installation is complete, we can clear our screen. Now let's verify whether we have Java installed or not. Okay, cool. This verifies that the required version of Java is installed. The next step is to configure our own Java home directory environment variable. To do this, we just need to know where our Java runtime is installed. By default on our CentOS system, Java is installed in /user/lib/jvm directory. Let's navigate to that directory. Inside this directory, there is another subdirectory where our specific version of JDK is installed. This could be slightly different for you depending on the exact version of JDK you installed. And here it is. Here is our java_home. Most programs which need Java runtime will need knowledge about this path. To make that possible, we typically set up this path in an environment variable called java_home. Now to set up our java_home environment variable for our current logged on user, which is the root user, we need to edit our bash_profile file. For that, we will execute the command vi:/.bash_profile. Here vi is the text editor we will use to edit our bash profile. And the tilde character represents our home directory, which is where our bash_profile lives. Now here, we need to execute these next steps. First of all, we need to export and set java_home variable. The value for this variable has to be the complete path where our Java runtime is installed. Let's copy it from here, and paste it right here in our bash profile file. Next, we need to add this path to our path variable as well. To do that, we will just append our Java home variable with a $sign with a semicolon to the already configured path variable. Since our actual runtime is installed under the bin directory, we will also append bin to our java_home path. Excellent. So that completes the process of setting up our Java home environment variable. For this change to take effect, let's reload our profile. We will execute su-. Now let's print out the value of our java_home environment variable by executing echo $java_home. Okay, as you can see, our java_home has been set up properly. Now our Java runtime will be available to our entire Linux system. Okay guys, since all the prerequisite details have been taken care of, let's install Jenkins. And since Jenkins Wiki is so helpful, all the necessary steps for Jenkins installation are also listed here. All we need is to just copy these commands, paste into our Linux command prompt, and execute them in sequence. We do not need sudo, because we are already logged in as the root user. Okay, it is complaining that we don't have wget command available on this Linux machine. We need to install that as well. Let's install it via yum install. We will execute yum install wget. Now after wget installation is complete, Let's try our Jenkins install step again. Okay, cool. Seems like that worked. With this command, we have added our Jenkins repository to the list of Yum repositories for installing Linux packages. Next, we need to import the Jenkins key. This will tell Yum exactly which version of the software and dependencies which need to be installed. Finally, after taking care of these steps, we can install Jenkins with a simple yum install command. We will confirm that we do want to download and install Jenkins and press Y here. Let's allow a few moments for the installation files to be downloaded and installed. After the installation is complete, we can go back to the wiki and see what we need to do next. Looks like we need to start Jenkins. On our CentOS Linux instance, we have a great utility called Service, which can start or stop our Jenkins instance. All you need to do is copy and execute this command. Service Jenkins start. Okay, great. Our Jenkins has started. Excellent! Now, obviously, it will not be very convenient if you have to start Jenkins manually every time. It will be great if this service started automatically as our Linux system boots up. This next command achieves just that. Let's copy and execute this command. chk config Jenkins OK. With this command, your Jenkins will start automatically anytime we start our Linux operating system. Great! Let's verify the status of Jenkins service once again. We will execute the command service Jenkins status. And as you can see, Jenkins is active and running now. We are now ready to access Jenkins to manage and configure it. Let's move further. Since this is a vanilla version of CentOS version 7, this particular Linux machine doesn't have any graphical interface at all. That is why the only way for us to access the Jenkins user interface is to navigate to our Jenkins instance from our Windows host machine using a web browser. But this virtual machine has been installed with Bridge Adapter mode. That is why the only way for us to access our Jenkins service is to manage special host files in Windows. To modify that file, we will launch command prompt on our Windows host with administrator privileges and navigate to Windows system directory. /drivers/etc. Here to edit our host file, we will open it up with Notepad. This host files helps the Windows system in DNS and IP resolution for our host. All we need is to get our IP address from our Linux machine and input it here in our host file. Also, to map this IP address, we need to get our host name from our Linux machine. We can get it by executing the command hostname, which in our case is jenkins.noodle.tetra, and also paste it here in our host file. Good. Now our Windows host can easily resolve the IP addresses for our Linux machine. Now, if we navigate to this URL, jenkins.noodle.tetra, in our browser window, it will direct us to the virtual machine. We will save and close our host file now. Great! Let's go to our browser and continue our configuration process. We will navigate to our Jenkins host name, with the default port for Jenkins, which is 8080. Okay, great. We are presented with this wizard for configuring our Jenkins instance. Because this is our fresh installation of Jenkins, in order to proceed further, we need to unlock it by supplying Jenkins administrator password. Jenkins configures a default initial administrator password, which can be found at this location. We will copy this path here and go back to our Ssh session for our Linux machine and open this file. And here is the initial password. Now click on Continue. Okay, excellent. Now our Jenkins instance has been unlocked, and we can proceed further. Next, Jenkins is presenting us with two options for configuring our Jenkins instance. Install suggested plugins. This means Jenkins will configure our instance with the recommended plugins. And the second option is select plugins to install, which naturally provides more control over configuration. For now, let's select the Select Plugins to Install so that you can get a behind-the-scenes look at all the plugins that are available for Jenkins. Jenkins has a vast community which has contributed hundreds of plugins to its vast ecosystem. As you can see, there are quite a few of them, and each one listed here has its own description. The selected plugins are the plugins which get installed when we select the Install Suggested Plugins option in the installation wizard. These are the most useful and popular plugins which Jenkins community have selected to be installed by default. These are the plugins we generally need to run necessary DevOps pipelines in typical environments. Of course, after installing these default plugins, we are free to install more plugins as per our requirements. We will focus on the most important and the most original plugins, which will be instrumental in running and using our Jenkins server effectively. Let's start with Dashboard View. Basically, all this plugin does is add visual diagrams to your jobs. For instance, if you have many jobs and they take a while to run, and you find it easier to visualize the process with some graphical statistic, then this dashboard view will provide that functionality to you. The most important plugin in the context of this course is the Pipeline plugin for continuous delivery. Pipeline plugin appeared in Jenkins version 1.5. At the very beginning, it was just a simple Groovy script which provided basic management for Jenkins jobs, but since that, it has matured into a much more useful plugin. The next plugin is Build Pipeline plugin. The plugin provides a graphical interface for managing pipelines. Let's select this plugin for our Jenkins install as well. Using this plugin, we will not need to write any codes or scripts to build our pipelines. With the help of this plugin, we can manage our jobs via the graphical interface it provides, which is much more user-friendly. Also, we need to install Copy Artifacts plugin, because only this plugin allows us to manage specific continuous integration and continuous delivery jobs. Source code management plugins are rather useful too. Here we select the plugin suitable for our respective source code management tools. In our case, we will use GitLab or GitHub. Maybe we will also use Bitbucket plugin. So let's select all these plugins. Next, the plugins that we'd select are SSH plugin and Publish over SSH plugin. Both these plugins are used to execute some commands over SSH to remote host or to pass some files over to SSH. We will install all these necessary plugins as we start building our build pipeline and we need that specific add-on. For now, to move forward efficiently, we will go back and select Install Suggested Plugins option. At this point, Jenkins will download all the necessary dependencies from the internet. That is why you must make sure that your Jenkins machine is connected to the internet. Let's wait and allow Jenkins to install necessary installation files before continuing further. After the installation of all dependencies, our Jenkins instance is now ready. Great, now we have successfully installed Jenkins and are ready to use it and manage it. Now we are ready to start using our Jenkins server and execute our first job on it. Let's click on this Start Using Jenkins button. Here we are on the Jenkins homepage. Let's discuss the most important Jenkins features. As we have already discussed in the introductory modules, basically, Jenkins is a continuous integration and continuous delivery platform. So at the core, Jenkins is only an engine which helps you build flexible and extensible DevOps pipelines. That means that all the shell commands, all the tools, frameworks, and the respective versions like Java, Maven, and other such dependencies used in Jenkins jobs are used from your Linux machine as the source. For instance, if you want to use Maven in one of your Jenkins jobs, but you don't have Maven installed in your CentOS system, Jenkins will not be able to execute the job, because it does not come pre-bundled with the tools. Or for instance, as part of your job execution, if a particular script executes echo $Java_home as a shell command, Jenkins will execute the command exactly as if you executed the command on your terminal window. The only difference is that Jenkins will execute the command under Jenkins identity. So with that understanding about Jenkins, let's start our deep dive journey and create our first new job. During this walkthrough, you will get familiar with various aspects of Jenkins Job. Let's name our job Test and select Freestyle Project as project type. Okay, let's begin from the very top of this page. Here is our project name. The description is just a descriptive text which explains what is the purpose of this job. This description value can be optional. Let's move on to other options. Please note that Jenkins provides us a lot of helpful tips. You can click here on the help icon right beside that field, and a very helpful descriptive tooltip is made available to you. This is quite handy, of course. Anyway, as you can see, there are tons of options available for Jenkins jobs, and we will guide you through the most necessary ones. First and foremost, let's make sure that we set this project to be a parameterized project by selecting this option. What does this mean? It means that you can add any parameters to your job. These parameters can be used as placeholders in your job definition, or steps and the actual values of the parameters can be passed in at runtime. It can be a special password, a special string parameter, file parameter, or some other options. These parameters make the job very flexible and portable. Let's move to the source code management section. In most build pipelines, this is one of the most important and basic steps we need to configure. Basically, your continuous integration and continuous delivery process start with these options. Because in most cases, the DevOps pipelines need to pull current source code for compiling and building the source and producing the build artifacts. Your source code could live in repositories like Git or Subversion or any other tool you use to manage your source code. Say we are using Git. Here we can select the option and input the repository URL for our Git repo. You can also specify your credentials and the particular branch of our source code repo we want to monitor. Let's move on to build triggers. Build after other projects are built. This particular option is really important, especially for our pipeline setup and configuration. Other options are build periodically, build when a change is pushed to GitHub, and poll SCM. Build periodically is based on cron expressions and will trigger builds based on the cron expression we define. If you are not familiar with cron expressions, you can click on the help icon and read all about it. Jenkins provides a pretty good tutorial right here. If we take a quick example and build a very simple cron expression with 5 asterisks, that means that we now have configured this job to build every 1 minute. Here, the first asterisk is for minutes, the second one for hours, next one is for the day of the month and for the weeks consecutively. The next option is to build when a change is pushed to GitHub. When we select this option, Jenkins monitors the Git repository and triggers a build when a code change is pushed to Git by a software engineer. This is a pretty good option to build your code actively and ensure no integration errors occur as developers introduce new code into the project. But it does have a drawback. Say if you have a very efficient software engineering team who is pushing code very frequently, then each commit will trigger a new build one after the other. That means that your Jenkins job will be quite busy building and rebuilding after each code push from your superstar team. That is why the last option of poll SCM is the most suitable option in most cases. It has all the benefits of build periodically and build when change is pushed to GitHub. With this option, you just need to manage what time and how often Jenkins will check the source code management system for changes. The source code management system could be Git or Subversion or any other system. Here in this example, we are specifying that Jenkins should check our source repo every 5 minutes for changes. If it detects some changes in the repo, Jenkins will trigger a build. But if there are no code changes detected, then Jenkins Job will just go back to sleep and wait for the next check to occur. In most real-world projects, we use poll SCM function. It is arguably the most logical option we can use in a multi-user environment. Let's move on to build environment. Here you will need to understand this particular option called delete workspace before build starts. Why is this important? Because as Jenkins starts to build and rebuild your source code for a build job, it may generate tons of temporary files which are stored in the workspace for a particular job. Since you can store multiple builds to preserve a historical track of your builds, you may end up with a lot of these files on your build server. Say if this particular project produces 1 gig of files and artifacts, and you decide to keep the last 10 builds on your server, then this project alone will require 10 gigs or more of disk space on your server. Moreover, these temporary files may also interfere with the new builds being run. That is why it is highly recommended that you select this option to delete workspace before build starts. It will keep the server disk usage in check and make the build process more robust and efficient. Now let's move on to the build section. Here you can define the specific steps that you want to add to your build job. For instance, if we select this menu, Add Build Step, we will be presented with some options like Execute Windows Batch Command, Execute Shell, Invoke Ant, Invoke Gradle, Invoke Maven. These are the default steps which are pre-installed by Jenkins and the default plugins we installed. As we install more plugins in our Jenkins instance, correspondingly more options will show up here. Out of these default options, the most useful one here is Execute Shell. This build step will execute shell commands on your Linux machine or on any other machine where your Jenkins instance is installed. There are these other options available to us as well, like Invoke Ant, Invoke Gradle, and Invoke Maven Target. These commands are built for tooling. For instance, we can use Maven package here to execute a Maven-specific step. But we can achieve the same effect by specifying mvm package with a shell command, and it will be almost the same as invoking top-level Maven package here. So it really comes down to our choice. Most of these tooling-specific steps could be accomplished just as easily via shell command steps. In some cases, though, it will be more convenient to pick a tool-specific step so that we can get the inbuilt configuration and validation user interface for that step with Jenkins user interface. The other main difference between these options is that this shell command will use the default settings on your Maven installation on your Linux instance, whereas a tool-specific step can be parameterized and can provide you more control. With the Maven-specific step, here you can set your Maven configuration by specifying a settings file, global settings, or even choose a specific JVM version of your Maven step. So this Maven step provides a lot more granular control. Let's move to the post-build actions. These post-build actions are also important for us. First of all, you need to know because of these post-build actions, you can create your pipelines by using the Build Other Projects option. In the previous versions of Jenkins, you were able to achieve this effect with the use of some special scripts. But now you can just select this option, Build Other Projects, and Jenkins will create and maintain dependencies between different Jenkins jobs. Also, you can archive the artifacts here, or even create a special email notification. Email notification will send you an email through an SMTP server as part of the job execution. Basically, it will notify you and your team about the status of a build job via an email. This will keep the team well informed about the build status and will help them resolve any issues readily. Here are some other important options available, like Git Publisher or Delete Workspace when build is done. These could be very useful in many situations. Another important point to note here is that in your Jenkins Job definition, you can use the environment variables, which are available on your Linux server. For instance, here we are using Java Home variable in the shell command step for your Jenkins jobs. There are other environment variables which are also generated by Jenkins. You can also use these variables in your jobs, like for example, build number. We can use this variable in a similar manner to our environment variable. We just need to use the $sign in front of the variable name. Echo $sign build number. At runtime, this value will be generated by Jenkins, and this variable will be replaced with the real value as the build is running. And we are free to use this variable value any way we see fit within our build job. For instance, we can use it in the name of our artifact output file name to distinguish artifacts originating from different builds. Okay, that is our first job, which is a very simple job. Let's save it. And now we can see it has been configured within our Jenkins server. To start this job, all we need to do is run it by clicking on this run icon. By the way, we can't see any progress right now. For that, we will need to refresh our page. In Jenkins, there is a handy option available on the top right corner which can enable auto refresh of our page. If it is not enabled, Jenkins will not automatically refresh this page and we won't see our progress unless we refresh the page manually. Only after refreshing will you see progress which confirms that our job has succeeded. Let's switch auto refresh on. And now let's rerun the job. This time around, Jenkins will automatically refresh the page and let us know about our job status, success, or failure. Now as you can see, the job ran for 0.1 seconds and there was no failure. Excellent! So we just configured and ran our first Jenkins job successfully. Now let's talk about Jenkins Pipeline. Jenkins Pipeline is a suite of plugins which support implementing and integrating continuous delivery pipelines into Jenkins. Pipeline provides an extensive set of tools for modeling simple to complex delivery pipelines. Before we get started with Jenkins pipelines, we first need to install the required Jenkins plugins. Let's do that now. The basic pipeline add-on is already installed in Jenkins, but we need a build pipeline plugin. Let's click on Manage link on the menu located on the left-hand side, which takes us to the configuration section of Jenkins. Here we click on Manage Plugins. Go to Available tab to list the available plugins. These are the plugins available in the Jenkins plugin ecosystem and have not yet been installed on this Jenkins instance. Here use the filter to search for build pipeline. And here it is. Let's install this plugin without restart. Now our Jenkins build pipeline plugin has been installed. Now that our pipeline plugins are installed and ready to go, we can create our first build pipeline view. To create our pipeline view, click plus icon right here and specify a name for our pipeline. For example, let's use tetra_noodle_pipeline_test and check build pipeline view. Click OK here. Now here we are in the detailed configuration section of our pipeline. This first field is the name of our first pipeline view. Here is the description, which is always optional. Here are some necessary options. First is title. Your pipeline view can have a title which is separate from the name of this pipeline job. Let's specify Title 1 for the pipeline title. Next, the most important option you don't want to miss is the initial job. This setting specifies the job that will start your pipeline. We will choose our test job because that is our only one available in our Jenkins instance for now. Let's go over other options. It is recommended that you check these options. Show pipeline project headers. Show pipeline parameters in project headers. Show pipeline parameters in revision box. All of these options will help you get more information about your pipeline build. All other options are really optional, and we will accept default values for them. Let's click Apply to set up our build pipeline view. Here it is, our first build pipeline with its own title. This view represents the steps involved in this pipeline in a visual manner. Besides being able to visualize our whole pipeline, we can also view the console output for our job steps. We just need to click on this little icon on the lower right corner and we get a detailed output for this job step in our pipeline. A quick little note about this user interface. If you have enabled auto refresh here, when you are viewing your console output, due to the auto refresh, Jenkins can automatically close this console pop-up. That is why if you don't want to have your console output closed automatically all the time, just disable auto refresh. Anyway, we will create a more realistic pipeline in the future, but for now, let's review how it works. Here, we already have one test job. Let's create another Jenkins project and name it Test 1. For the project type, we will pick Freestyle Project again. We won't make any specific changes in the settings here, but just execute a shell command to print out the build number. These are simplistic jobs which do not accomplish much. We just need these jobs to go over the basic pipeline concepts. We will create much more useful Jenkins jobs in the upcoming videos. The idea here is to show you that in order to build our pipeline, we need to chain our jobs to be executed one after the other. And the way to do this is by editing our first job, and we need to configure it with the post-build action. Let's go to the Jenkins homepage, and here click on our test build job, which is our first job in the pipeline. Now let's click on the configure menu on the left-hand side. Scroll down to the bottom of the page and configure one post-build action. The post-build action we will select here will be of type build other projects. And for projects to build field, we will pick the second job in our Jenkins instance we just created called Test 1. So basically, what we are saying here is that when test project is completed and is stable, then build our Test 1 project. So you see how this is taking the shape of a chain of projects or a pipeline. Let's save this job and go for our tetra_noodle_pipeline_test view. Here we can see when our first job will trigger, and after it is successfully done building, our next job will be triggered automatically. Let's try it out. Don't forget that we need to refresh the page manually to review progress since we have disabled auto refresh. Here it is. Now we can see that after our test job was successfully built and once completed, it automatically triggered the build for the second test job, and both jobs have turned green to signify that both have succeeded. So why exactly do we need the pipeline and build pipeline add-on? Well, in real-world projects, where we have tens or hundreds of components to build, we need to ensure that all the components are working properly even as changes occur in only a few components. For instance, the middle layer components may depend on data access components, and web components may depend on middle layer components. Granted, similar chaining can be achieved via post-build actions, but it is quite difficult to visualize multiple build chains just using these post-build actions. Build Pipeline Plugin provides a much friendlier graphical interface, which helps us visualize the whole pipeline at a glance. For example, here is an example of a real-world pipeline. This particular pipeline starts with this git source job, which pulls the source from our git repo. This git job can stage the source and then trigger two separate jobs, analysis and sonar analysis. Sonar is a very cool code analysis tool. This is an example of splitting a pipeline into parallel sub-pipelines. The analysis job itself can trigger another job called deploy for customer. And then analyze sonar job can trigger a job called deploy for developers. So this is a good example of a real-world build pipeline. This pipeline serves multiple purposes. It builds the source. It analyzes the source code using the sonar tool. Moreover, it also triggers two different deployments into different environments. All this is triggered off by a single source change. And when we wrap all these steps into a build pipeline, Jenkins helps us visualize everything in a very clean and intuitive way. Not only that, this also gets updated as the pipeline gets executed. So we can watch the progress of our pipeline in real time. Let's enable auto refresh and see what we've got here. Good. Our Git job triggered the other two analysis jobs. And there we go. It looks like all our jobs were successfully built at the end of this pipeline. We should have 2 successful code deployments, deployment for the customer and another deployment for developers. Anyway, we will look to build Pipeline Plugin and its job more closely in upcoming videos. Now we install another tool called Artifactory. Artifactory is an open source repository manager which is published and maintained by a company called JFrog. What is a repository manager? Well, Artifactory is a special repository for your artifacts. You produce these artifacts as part of your continuous integration, continuous delivery, and deployment processes when you compile and build your applications or create web applications, even when you create some packages. These artifacts could be some Java compiled code, HTML code, configuration files, or any other type of file-based components produced by these processes and which are necessary to run or configure your target system. One of the most useful attributes of this Artifacts Repository Manager is that once we have stored our artifacts in the repository, it is accessible to all our team members and they can download these artifacts from anywhere, anytime. Let's take a real-world scenario. Say there is a large software development team, which is working on a project and there is a configured continuous integration and continuous delivery process in place. After the source code is processed by the CI-CD pipeline, it will produce the artifacts from the source code. The team has an option to store these artifacts on a network storage share, but this becomes cluttered very quickly. It is hard to keep track of the versioning of the artifacts, hard to implement security and access rules. This is where a repository manager like Artifactory shines. The team can store their artifacts in this repository, and their artifacts could be distributed to other team members, partners, customers in a reliable, efficient, secure, and stable manner. What's more, these repositories integrate seamlessly with Jenkins, so the whole process of storing and distributing the artifacts could be completely automated. Okay, now that we know what Artifactory is, let's go through the installation process and start by discussing our environment. A word of advice here. If possible, you should install Artifactory on a dedicated physical or virtual server, which is separate from the Jenkins server. This is to ensure that there is no conflict between these servers. Moreover, in the real-world scenario, these two servers need to be accessible by a different group of people, so it's a good general practice as well. So, for installing Artifactory, we have spun up a new virtual machine. We are working here with the second virtual machine, which also has CentOS Linux installed on it. To get complete version information for your Linux distribution, all you need is to execute cat/proc/version. As you can see here, we have the Red Hat edition of Linux, and it is the CentOS distribution. So, just like we did with Jenkins Installation, we need to take care of the prerequisites for the installation. Furthermore, just like Jenkins, Artifactory also requires Java to install and run. And specifically, it needs the Java version from Oracle. To install the required Java version, you can go to oracle.com/tetnetwork/downloads. And here you will find the version of Java you need. If you are having trouble finding this page, you can Google download Java, and the first link should lead you to this page. On this page, select the appropriate version based on the operating system you are running. It may be Linux or Windows. Just remember that you need JDK. Just for your information, JDK is short for Java Development Kit, and this development kit is an essential prerequisite for Artifactory installation. Just as a reminder, we can install Java using any package manager as well. After installing Java, we can confirm the version by executing java-version. So here we can verify that we have the runtime environment installed, and Java version 1.8.0_101. So this pretty much satisfies the minimum requirements for our Artifactory installation. Now let's set up our Java home. To do that, you need to execute the shell command, update-alternatives-display Java. And this last path in this list is our Java home that we need to set in our bash profile. We will open our bash profile with the VI editor. Here we will add the path that we copied earlier, and also set up an environment variable for Java_home. Okay, that looks good. Now let's save our bash profile. Let's reload our user and check our Java home. Now we can continue with the installation of Artifactory. To start installing Artifactory open source, all you need to do is go to JFrog's installation guide for Artifactory. Here you can just choose the necessary installation package based on the operating system that you are running. It is recommended that you use a package manager like RPM to make the installation process easy and painless. Let's choose Artifactory Open Source Edition. Artifactory also has a commercial edition with more enhanced features. For now, we can just use the open source edition, which is free for use. Let's copy-paste these shell commands to install our instance of Artifactory using the RPM distribution. First of all, we will download our Artifactory installation repository information using the wget command. If you don't have the wget command, you can install it via the yum package manager. After the installation is complete, we can use wget. Good. With this wget, now the Artifactory repository information installation package has been downloaded onto our system. This file contains the information, which our RPM package manager can use to download and install the required software. The next step is to move this repository information to the target directory where our package manager will become aware of this repository and register it as one of the known repositories. And now the last step is to use the yum install command and install the Artifactory open source edition. Let's give it a few minutes. There! The installation is now complete. After the installation is complete, we can now start our Artifactory instance by using the service commands. We will execute service Artifactory start, and we will get some information about Artifactory, which confirms that Artifactory has been successfully installed and started on our server. Artifactory is built on top of Tomcat Application Server. That is why when we install Artifactory open source, it also installs Apache Tomcat Server. So how does our Artifactory work? Let's check it out. Let's try to access the Apache Tomcat instance which was installed with the Artifactory. Let's open a new tab in the browser and navigate to server.noodle.tetra:8081/Artifactory. Please note the complete URL. It is important to append Artifactory to this URL. Why should we do this? We do this because our Artifactory open source is based on Apache Tomcat. Apache Tomcat is used to deploy your Java servlets and JSPs. So in your Java project, you can build your WAR, short for Web Archive, file and just drop it in the deploy directory with Tomcat. So basically in this setup, Apache Tomcat is the HTTP server, serving HTTP requests, and it is also the servlet and JSP server container. When we navigate to our Artifactory instance, we are basically accessing a web application which has been deployed into Apache Tomcat server instance. Artifactory is just a Java web application which has been deployed as a WAR file into Apache Tomcat. Nothing more, nothing less. What is the significance of this? It means that after installation of Artifactory, you will have a full installation of Apache Tomcat on your server. And this server is not exclusive to Artifactory only. You can just as easily install other Tomcat web apps and Tomcat admin web apps by executing the yum install command into this instance of Apache Tomcat. This is convenient because if you are working with Artifactory, there is a good chance you will be working with other Java-based web applications. So you can unify the applications and your Artifactory instance into the same Apache Tomcat server. Apache Tomcat got installed because Artifactory has a dependency on it. Our package manager duly noted this dependency and installed the necessary components transparently. It also configured the necessary components for our operating system. Let's open the configuration file, tomcat.conf. Let's update this line and update the Java OPTS configuration with an updated configuration. This will optimize the use of JVM and help run Apache Tomcat more smoothly. After editing our configuration file, let's also edit our users. This Tomcat users XML file is a Tomcat configuration file which stores all the users and their respective roles who have access to their Tomcat instance. Here you can edit users and their roles to fit the requirements of your environment. For now, let's review the process of creating a superuser. Within the context of Apache Tomcat, a superuser is similar to an administrator user, who has access to pretty much all the functionality provided by the software component. The default file already has some boilerplate XML code to configure our users and roles. We can just repurpose this and uncomment these lines of XML code. And as for the user, we will add a username of admin and provide a password. And that is all. We have created a new user called admin, which has a password of admin. We also assign all the relevant roles to this user, and as such, this user has all the necessary permissions and is effectively our super user. Let's save this file and run our Tomcat server instance. We will execute the command systemctl start tomcat. Okay, to confirm, let's check its status by executing systemctl status tomcat. Looks like it's running now. We can access our Tomcat instance now. All we need to do is use our server DNS name, but with 8080 port, because that is the default port which Apache Tomcat uses. server.noodle.tetra:8080. Here we are. This is the default homepage for Apache Tomcat where we can check the status of the server, and we can even manage our app's deployment in our instance of Tomcat. In order to enter the management area, we need to provide our credentials. We will use the admin user credentials we just set up. As we can see here, all our web applications are listed here. You can see all the folders in a Tomcat in the root of the Tomcat server. Getting back to our Artifactory instance, we can see it here. You can see that this repository provides tons of features. But since we deployed the open source edition, certain features are not available. Even with the free features available, Artifactory is an excellent tool to manage your artifacts. But in case you need access to more commercial features, you will need to purchase the product. The features annotated with the not available are the features which can only be accessed in the paid version of the software. Let's explore our repository. Here in the Artifacts package, we can review and manage the storage which is managed by Artifactory to store and deploy our artifacts. As we build and deploy new artifacts via our CI-CD processes, they will all show up here. Artifactory will maintain and manage the location, storage, versioning, and security of all our artifacts. Moving along, we also have this tab called Build Browser. Artifactory has built-in capability to connect our CI/CD infrastructure. For instance, Artifactory can connect to our Jenkins infrastructure or even JetBrains TeamCity infrastructure. So this screen can pull the information about the build jobs from these integrated servers and show them here. So far, we have been browsing the Artifactory instance as an anonymous user. Let's log on by clicking on this link at the top right corner. We will use the credentials of our admin user. And now we are logged into our server as a super user. Now we can manage our Artifactory system and configure all these options and settings. Remember that options which are marked with an asterisk are not free, and you need to pay for it and buy the license. Let's end this module with a quick recap. In this module, first we went through the process of installing and configuring Jenkins. Then we created a simple Jenkins job and ran it successfully. Next, we configured pipeline plugins and configured a pipeline and ran it successfully. Last but not least, we also installed Artifactory Repository Manager. Stay tuned for the next module! Hello, and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we went through detailed steps for installing and configuring our Jenkins instance, and we also ran some jobs on our Jenkins server. After installing our Jenkins instance and going through a simple pipeline job, now it is time to kick things into high gear. In this module, we will take a look at creation of CI and CD pipelines for real-world projects. So let's get started. Before we dive into the project, let's get familiar with the overall structure of the project and the components we will be using in this project. This sample project is a simple Java-based REST API project which exposes one simple endpoint. We picked a simplistic project for these demos because our main focus will be the integration of these projects with our Jenkins pipeline. In your environment, you could follow similar steps to integrate any similar project to build with your Jenkins pipeline. Anyway, so our source code will be managed by our source control provider, which in our case is Git. For our Git source control, we will use Bitbucket. Bitbucket is a web-based source control hosting service for projects that use Git revision control systems. Bitbucket offers both commercial plans and free accounts. It offers free accounts with an unlimited number of private repositories. Bitbucket is very similar to GitHub in the functionality it provides. For our build framework, we will use Gradle. Gradle is an open-source build automation system that builds upon the concepts of Apache Ant and Apache Maven and introduces a Groovy-based domain-specific language, DSL, instead of the XML format used by Apache Maven when declaring the project configuration. We will build our source code automatically using a sophisticated Jenkins job. This job will pull the source from our Git repository and produce the required Java artifacts. These artifacts will be stored in an artifact repository manager. A repository manager is a software tool designed to optimize the download and storage of binary files used and produced in software development. It centralizes the management of all the binary artifacts generated and used by the organization to overcome the complexity arising from the diversity of binary artifact types, their position in the overall workflow, and the dependencies between them. A repository is a software repository for packages, artifacts, and their corresponding metadata. It can be used to store binary files produced by an organization itself, such as product releases and nightly product builds, or for third-party binaries which must be treated differently for both technical and legal reasons. For the repository manager, we will use a product called JFrog Artifactory. Artifactory is a universal artifact repository manager which fully supports software packages created by any language or technology, which means we can use it to store artifacts produced from Java, .NET, Python, or any other framework. Artifactory integrates with all major CI, CD, and DevOps tools like Jenkins, TeamCity, TFS, etc. And it provides an end-to-end, automated, and reliable solution for tracking artifacts from development to production. Everything we are using here is completely free and open source. Alright folks, let's start by reviewing our source code for our API project. Here we have navigated to our Bitbucket repository for our project, and we were looking at the master branch of our project. Since we're using Gradle as our build system, we need to have this build.gradle file in the root folder of our project. This build.gradle file is the build definition file for our Gradle build system. It contains information and instructions for Gradle to build our project along with all the required dependencies. This build definition file is a prerequisite for Gradle to be able to build our project, so please make sure this build.gradle file is located precisely in your root folder. Gradle will search for this build definition file within the internal directory structure of your project. Let's review our build definition. At the top is the build script, and it lists the repositories we are going to use and the dependencies for this project. These dependencies signify that we will be using Artifactory for storing our artifacts. Same goes for plugins here. And we are using JUnit for running our unit tests. And last but not least, we have some more options specified for Artifactory. It has information like the target URL for our Artifactory instance. Now let's head back to our source code repository hosted on Bitbucket and navigate to our API folder, where we can see we have this API called person list, and we also have this package.html file. Okay, so after reviewing our source files, let's move ahead with building our continuous integration and continuous delivery pipeline. Let's get back to our Jenkins homepage and create a new Jenkins job. Click on this handy link, Create New Jobs, to start a new job creation wizard. Let's name the project Gradle_build_tetranoodle and choose Freestyle Project as the project type. Okay, great. Let's start configuring our job. First of all, let's configure the option to discard old builds. Let's say we want to keep our builds for 4 days, and we want the last 6 builds to be kept for historical and tracking purposes. This configuration will take care of that. You can adjust these numbers based on your preference. Next, we need to configure our source code management so that Jenkins can pull our source code from our repository. Since we are using Git for our source code, we select Git as our selection. To integrate our Jenkins instance with our Bitbucket repository, we will need to provide the repository URL for our repository. You can get this repository URL by navigating to Bitbucket and clicking on the Overview link. The repository link is available here at the top right corner. We will copy it verbatim and paste it back into our Jenkins job configuration under the repository URL field. After configuring our repository, we can also configure credentials so that our Jenkins instance can access our repository. But in our case, we can accept the default value of none because our source repository is public and we do not really need any credentials to be able to access it. That means that anyone can clone our project without any credentials. If our project were private, we would have specified credentials right here in our build definition. You can insert username here and your password for the Bitbucket account, just like this. Okay, it looks like everything is configured correctly. Let's apply these settings and save our job. By the way, the process of integrating Jenkins and Bitbucket is really simple. All you needed was the public URL of a repository to enable this integration. But in case you are using a different source code provider, you may need to install additional plugins to integrate Jenkins with your target source control provider. For instance, say you want GitLab as your source control provider. Then you would need to install the GitLab plugin into Jenkins to make them work together. Let's quickly see how we can configure a different SCM, like GitLab, with Jenkins. Let's click on Manage Jenkins, link on the left menu, and click on Manage Plugins. Now switch to Available tab to access the list of plugins which are available to us. Here we will search for GitLab for our required plugin. This GitLab plugin will allow us to connect our Jenkins instance with GitLab. The actual process of integration is pretty similar to how we connected our Jenkins plugin with Bitbucket. The only difference is that you need this plugin in order to enable the integration with GitLab. You can check out this and other plugins in case you have some special requirements to satisfy. Okay, great. Let's continue and connect our Jenkins with Artifactory open source. Here we are in our Artifactory repository manager. As discussed earlier, Artifactory is a special repository based on Apache Tomcat that can easily store all your artifacts. What does it mean to store artifacts? When a software build process, for example, a Jenkins build with our little REST API, is completed with the help of Gradle, in the end it will produce a jar or war file. This jar or war file could be an executable or a deployable file, and this file is called an artifact. Our artifact repository manager can easily manage multiple versions of this file. Once the artifact has been added to our Artifactory repository manager, individuals like our team members or partners who have access to this repository can review the artifact, its version, the metadata, etc. They can browse the available versions and download the required version and install it on their system. The whole workflow to publish, manage, and consume these artifacts becomes much smoother and secure using a repository manager like Artifactory. Alright, before we move forward, let's review our environment for the Artifactory instance. Basically, we have deployed Artifactory on a local virtual machine, and this virtual machine has been deployed with a bridged network mode, which means we will not be able to resolve the IP address for our virtual machine directly via our DNS server. So in order to get around that problem, we will just update our host files to force a DNS resolution to our target machine. We will get the IP address from our virtual machine by executing IPA command, and in order to get the complete host name, we will just execute the command hostname. First, we will copy the target IP address from our virtual machine. In our case, this IP address is 192.168.0.104. We will map it to a DNS URL of art.noodle.tetra. Now let's first map this IP and DNS URL on our main host Windows machine. We will open a new Windows command prompt with administrator privileges and navigate to System folder and then to /drivers /etc. folder, and here we will need to open the host file with a text editor like Notepad. We have already added the entry to map our Artifactory machine's IP address with the desired DNS URL. After configuring it as so, our host machine will be able to access our Artifactory instance using the DNS URL. Furthermore, we need to do similar configuration changes on our Jenkins host machine as well, so that it can also easily access our Artifactory instance. So let's head to our Jenkins virtual machine and edit our host file on our Linux instance with the VI editor. You will notice the structure of the host file is very similar to the host files on Windows. And now we have mapped our DNS entries for the Artifactory instance by updating our host files. And because of the special architecture of Jenkins, we need to create two entries. One for the base DNS host name, art.noodle.tetra, and another one for the HTTP endpoint for our Artifactory server, http://art.noodle.tetra/, so that Jenkins can access both these endpoints without any issues. The next step is to install a special add-on to integrate Artifactory with Jenkins. Let's navigate to the Manage Jenkins screen and click on Manage Plugins. Here we are in the plugin management area. If you have not installed the Artifactory plugin, then you will need to access the Available tab to look for the Artifactory plugin. But on this particular Jenkins instance, we have already installed this particular plugin. So in this case, it is listed on the Installed tab. In order to install this plugin, you will need to go to the available list of plugins and search for the Artifactory plugin. This plugin will allow you to connect your Jenkins with Artifactory open source instance, which we installed in previous demos. Once you find this plugin, you will need to select and install the plugin in your Jenkins instance. The Artifactory plugin also requires us to provide additional configuration to be able to connect to Artifactory. So let's make sure it is properly configured now. We will click on Manage Jenkins menu on the left-hand side and then click on Configure System, and then on the configuration screen. Scroll down to find the Artifactory section. This section was added into our configuration page after we installed the Artifactory plugin. Currently, Jenkins does not know anything about our Artifactory server. So let's click Add to add a new Artifactory server configuration. First, we need to provide an identifier for our server. The value could be anything, as long as it is unique. We will just use the artifact server DNS URL to make it easier to recognize and remember. Next, we need to provide the URL where our Artifactory server is installed. If you recall, we already updated our host files with the required DNS mapping. So our Jenkins server should be able to connect our Artifactory server using this endpoint without a problem. After that, all we need to do is specify the username and password for our Artifactory server. We will use the administrator user we set up earlier for Artifactory. One word of caution. For production environments, please use a specific user with the least amount of privileges. For the purpose of this course and for the sake of convenience, we are using the admin user. Now, after setting up our server like so, let's test our connection. Okay, the connection failed. We forgot to append Artifactory to our URL. There we go. After fixing that minor error, let's test the connection again. Great! Our Jenkins was able to connect successfully to our Artifactory server, and as a part of this initial handshake, it also downloaded some version information about our server, which further verifies that Jenkins is successfully connecting to the right Artifactory server. Now that Artifactory is connected to the Jenkins server, we can continue to configure our build job for our Java API code. Now let's click on the Gradle_build_tetranoodle job, and on this build homepage, let's click on Configure menu on the left side to update its build definition. Scroll down to the build environment section, and here we will select the Gradle Artifactory integration. Now we need to select the target Artifactory server. This job definition already recognized the server which we configured in the global Jenkins settings, and it is being listed here in the list of valid known Artifactory servers. Now, since we only have one Artifactory server configured, we will just pick this default value. Next, we need to pick the target repository within the Artifactory server where we want to publish our artifacts. Rather than manually type the name and copy and paste it from Artifactory, we can click on this refresh button, and Jenkins will pull the list of repositories from the target Artifactory server. As you can see, the plugin is quite user-friendly and easy to use. For now, let's pick this repository, Release Local. We will not change anything under resolution details because it is not applicable to the current project we are trying to build. If the Jenkins job is using a plugin to interact with the Artifactory server, we need to enable this option. Project uses the Artifactory Gradle plugin. Our case, for example, we are using the Artifactory plugin, as we can verify by reviewing our build.gradle file. Here is the plugin, com.jfrog.artifactory, which means that within our Jenkins build, we definitely must enable this option. Otherwise, our build will not be wired up correctly. Let's make sure this option, publish artifacts to Artifactory, is also enabled because that is exactly what we need to do. Most other options are optional and we can accept the default values for them. Now let's go to the build section and add a build step. Build steps are the basic building blocks for the Jenkins freestyle build process. These steps are what define the flow of a build job and instruct Jenkins exactly how to build the project. A build job may have one step or more. It may even occasionally have none. In a freestyle build, you can add as many build steps as you want to the build section of your project configuration. There are various types of build steps available to us. Since we are using Gradle as our build framework, let's pick Invoke Gradle Script. And now, a bunch of new options are available to us for configuring this Gradle script step. Let's take a closer look at this build action, because it is a really important step for this build job. Jenkins presents us with two options to configure this Invoke Gradle script. The first one is to simply invoke Gradle, where all we need to do is choose the Gradle version. And the second option is to choose a Gradle Wrapper. Most tools require installation on your computer before you can use them. If the installation and configuration of these tools is easy, then it is not a big issue. We can install them manually and we are good to go. But in some cases, it can be an unnecessary burden on the users of the build. Before they can build their projects, they have to go through a series of manual installation and configuration tasks for all the tools they intend to use in their build jobs. This could be quite a tedious task. More importantly, as new versions of these tools are released, we also need to worry about whether the server will have the compatible version of the tool installed. What if they're building an old version of the software? The Gradle Wrapper solves both these problems and is the preferred way of starting a Gradle build. Let's discuss the Invoke Gradle option first. This option allows us to use one of the particular versions of Gradle Wrapper which has been installed and configured within the current instance of your Jenkins server. As alluded to earlier, Gradle Wrapper is the Gradle-provided mechanism to embed the use of a specific Gradle version in a build. If the required version is not available, the wrapper installs the necessary version before continuing with the build. In order to use the Invoke Gradle option, we need to configure a particular version of Gradle. Let's do that now. We will go to Jenkins homepage and then click on Manage Jenkins menu on the left-hand side, then click on the Global Tool Configuration link. The Gradle plugin for Jenkins provides automatic installation for Gradle, which can be performed by directly downloading from the Gradle website, extracting a compressed file, or executing some shell commands. Besides that, for Jenkins instances which already have Gradle installed, the plugin can be manually configured by unchecking the Install Automatically checkbox and providing the base path of installation. This path is configured via the Gradle home environment variable. In fact, the name of the variable could be anything. Once configured, Jenkins will attempt to use this particular installation of Gradle for any Gradle-related build steps. Jenkins will use the Gradle executable from the bin directory of your Gradle home. If the Jenkins instance does not have Gradle installed, you can also pick this option to install Gradle automatically. Once we have configured our Gradle instance, we can use it for any of our jobs. Speaking of which, let's head back to our job build definition. Here we can see that if we select Invoke Gradle option, we are provided with the list of installed and configured Gradle instances. In this case, the only instance we have is the instance appropriately named Gradle. Having said that, the recommended option is to use the Gradle Wrapper for these types of build tasks. Why is that? Because Gradle Wrapper allows Jenkins to download the necessary files and executables from the internet exactly as needed by the Jenkins build job. What does that mean? Well, it means that anytime any Jenkins job needs Gradle, this wrapper will take care of the installation and configuration of Gradle. It is a much more efficient and robust method to use this option, especially if you're deploying the job on multiple servers, in which case you can do away with the hassle of installing and configuring Gradle manually. The Gradle Wrapper will take care of it for you. All we need to do is click here and enable this option, Make Gradle W Executable, and to apply and save. Gradle W is the command for Gradle Wrapper. With that, we have completed the build definition for our job. And now we are ready to run our first job and review the results. Let's click on the Build Now button to kick off a new build. You will notice that a new build is now showing up in the build history list. Let's go to console output to monitor this build in real time. This is the output log, which Jenkins produces as it is running our Jenkins job. It is fairly verbose and could be daunting to look at initially. But once you get familiar with it, you will find it invaluable to monitor and troubleshoot your jobs in real time. Let's review the log for the current execution. First, we can see that our job is trying to connect to our Git repository. It finds the latest revisions or commits in our source repository. Then it pulls all the source code for the latest revision of our API project. Once downloaded, Jenkins will start to build our source code. For building our source, it is going to use the Gradle framework. But notice how it is using the Gradle W execution, which is the Gradle Wrapper with this special option of Artifactory Publish. So as you can see, Gradle Wrapper is downloading the necessary Gradle version from the internet along with all the necessary dependencies. Let's wait for a few moments for it to install and configure the required files. Now it looks like our code has been successfully built and our job has produced a jar file. Last but not least, our job has also successfully deployed our jar artifact along with the build descriptor into the target repository within our Artifactory server. The job also outputs a handy link to the location where our artifacts were deployed. Let's click on this link and head to our Artifactory server and verify the deployment. And here we are. We are in the Build Browser section of our Artifactory server, where it is providing us all the metadata information about this build. We see that the name of this build is Gradle_build_tetranoodle, and it is the first build number. To check our artifact, we need to go to the Artifactory repository browser and move to the repository where we instructed our Jenkins job to deploy the artifacts to. If you recall, we picked ext-release-local. Here it is. Underneath this repo, we see our jar file. That is the artifact which Jenkins created as an output of our build job. Once selected, we have a lot more metadata information available about this artifact. Let's recap what you learned in this module. First, you implemented a Jenkins job for the Java API project. Next, you installed and configured our Artifactory plugin for Jenkins. Then you updated your Jenkins job and integrated it with Artifactory. Last but not least, you ran your job and deployed the build artifacts from your Jenkins server into your artifact repository. Stay tuned for the next module, where we will continue with our CI and CD pipeline with Maven. Hello, and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we built a continuous integration and continuous delivery pipeline for a Java API project using Jenkins, Gradle, and Artifactory. In this module, we will build a similar pipeline, but with another build tool called Maven. So let's get started. In this session, we will create a new continuous integration and continuous delivery pipeline for a simple web Java application. Before we dive into the project, let's get familiar with the overall structure of the project and the components we will be using for it. As usual, we will store our Java source code in Bitbucket. But this time around, we will use Maven as our build framework. Maven is a build automation tool used primarily for Java projects. Maven addresses two aspects of building software. First, it describes how software is built, and second, it describes its dependencies. Contrary to preceding tools like Apache Ant, it uses conventions for the build procedure, and only exceptions need to be written down. An XML file describes the software project being built, its dependencies on other external modules and components, the build order, directories, and required plugins. It comes with predefined targets for performing certain well-defined tasks, such as compilation of code and its packaging. Maven dynamically downloads Java libraries and Maven plugins from one or more repositories, such as Maven 2 Central Repository, and stores them in a local cache. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and other languages. The Maven project itself is hosted by the Apache Software Foundation. After building our source code, we will deploy our web application onto an Apache Tomcat server. Alright, let's start by reviewing our source code for our Java web application project. Since our application will be built using Maven Build Framework, the most important file we should look at first and foremost is the POM XML file, which acts as the build definition file for Maven. This file can be found in the root of the project because that is where Maven expects it to reside. A project object model, or POM, is the fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. For this project, we have chosen to demo a build which builds multiple modules as part of the same build definition. Right now, we only have one module definition in this POM XML, called multi3. But if and when we add new modules, we can build those modules with the same POM XML file, and each one of those modules may produce a different artifact like jar or war file. The minimum requirements for a POM are project root, model version, group ID, the ID of the project's group, artifact ID, the ID of the artifact or the project, version, the version of the artifact under the specified group. A POM requires that its group ID, artifact ID, and version be configured. These three values form the project's fully qualified artifact name. This is in the form of group ID, artifact ID, version. So for our example, its fully qualified artifact name is tutorial.noodle.tetra, multi:3.9-tetra. If the configuration details are not specified, Maven will use the default values for those missing settings. One of these default values is the packaging type. Every Maven project has a packaging type. If it is not specified in the POM, then the default value jar will be used. Besides that, we also specify a name for our build project, which in this case is Simple Multi-Modules Build. For testing our code, we are specifying that we will use JUnit test framework. We will also use maven.war.plugin for creating a Java web application and another plugin for Maven source. Okay, now let's explore the multi-3 package and the source files that we have created within this application. We will navigate back up into our source repository, and here it is. This, in fact, is a very simple application and has its own POM XML. Let's review it now. The packaging type here has been specified as var, and we have also updated the name to multi-3, corresponding to the name of the application we are trying to deploy. And here under the plugins, we are again using the Maven war plugin for creation of our war file. What is a war file? And how does it differ from a jar file? Well, both files are similar in nature in that these files are simply zipped files using the Java jar tool. But these files are created for different purposes. The jar files contains libraries, resources, and accessory files like property files. The war file contains the web application that can be deployed on the servlet JSP container. The war file contains JSP, HTML, JavaScript, and other files necessary for the development of web applications. We can deploy our application into Tomcat Apache or any other application server using the war files. Okay, so after reviewing our source files, let's move ahead with building our continuous integration and continuous delivery CI-CD pipeline. Here we are on our home page for Jenkins. We will click on New Item to create a Jenkins job. First, let's name it git_source because this job will take a source code from Git. And we will select Freestyle Project as the project type and click OK. First of all, let's customize the settings for discarding our old builds. This is a good practice which helps keep our build history clean and efficient. Let's keep the builds for 2 days and keep only the last 5 builds. Next, we need to manage our source code repository configuration. Here again, we will need to specify the URL for our Git repository. We will head to our Bitbucket console and click on the Overview tab. And here on the right upper corner, we will find our Git repo URL. Let's copy it and paste it here in our Jenkins Job definition. Now we have kept our repo access open to the public, so there is no need to add any Git credentials. If you are working with a private or enterprise repo and you need to pass in credentials to access your source code, you can do so by clicking on this Add Credentials button. Now, let's proceed with the next steps in our Jenkins Job configuration. Scroll down to the Build Environment section and select this option, Delete Workspace before build starts. This is a really important step. It ensures that all builds are valid, so we should take extra care to clean out the workspace. This makes sure that the leftovers from previous builds do not affect the current build. Now we are ready to move to the meat of this job definition, which is to define our build steps. We will scroll down to the Build section and click on Add Build Step. As we reviewed earlier, we have various options for build steps available here. Besides the out-of-the-box options like Execute Shell, Execute Windows Batch command, new options get added to this menu as we install relevant add-ons to Jenkins. Since our project is a Maven project, with POM XML available in the root of the project, we will need to run this build job as a Maven build. This can be accomplished in 3 ways. We can just execute shell command to execute the required build steps, or we can pick Invoke Artifactory Maven 3. This option is available to us by the virtue of the Artifactory Plugin. The Jenkins Artifactory Plugin supports running Maven 3 builds from freestyle jobs by using a Maven 3 build step plus a build environment section for the Artifactory Maven 3 integration, artifact and build information deployment. Or we can just pick Invoke top-level Maven targets. Invoke Maven 3 is provided by the Artifactory plugin, whereas Invoke top-level Maven targets is a part of the standard Jenkins distribution. What is the difference and what is better to use? Let's review a couple of these options. If we use the shell command, we will configure our job to execute the shell command mvn package. Here, this command will use the default version of Maven, which has been installed and configured on the Jenkins server, which in our case is Maven 3.0. So the shell command will use all the default values for the configuration and settings for the running of Maven. If we want to use Invoke top-level Maven targets, here we can specify our goals, and after clicking this Advanced button, we can also specify our properties, options, and settings file. So this gives us much more flexibility and control over our builds. By the way, if you need to use a particular version of Maven, we can configure it in Global Tool Configuration, just like we configured Gradle in the previous session. Let's review it quickly. We will go to Jenkins homepage. Then click on the Manage Jenkins menu, and then click on Global Tool Configuration. Here on this Global Configuration page, find the section for Maven, and to add a particular version of Maven, we can click on this Add Maven button. And now, Jenkins will allow us to download and install this particular version of Maven on our Jenkins server. The Install Automatically option will ensure the required version of Maven is automatically downloaded and installed whenever a build needs it. Here we can specify a particular name for our Maven instance and also customize the Maven home path for our Maven instance. So this is how you can have full control over the Maven installation. For now, we will keep things simple and use the default Maven installation for our job via a shell command. Let's head back to the job definition. For this job, we will be creating a pipeline for our build. In order to build this pipeline, we will select a post-build action to chain our job actions in the pipeline. For our post-build action, we will select Archive the Artifacts option. What does this mean? Well, after our mvn package command runs, it will build our simple Java web application and produce a WAR file. This WAR file will be copied into our source code directory structure under the module multi3 folder, under the target subfolder. These artifacts can be managed by our post-build action and archived. All we need to do is supply a path to our artifacts. Let's specify that path. multi3/target/**war. This will look for all WAR files which are created in this target folder as a result of our build. Okay, now our build definition is ready. Let's apply these settings by clicking on the Apply button and then clicking Save. Great! We have configured our first job. Now that we have configured our job, let's run it and verify everything has been set up correctly. Let's get back to the Jenkins homepage and click on our new job. Here we will click this Build Now on the left menu to run our build and verify everything has been wired up correctly. Okay, our build has started. Let's check out the console output for our build. Let's give it a minute to finish the build. You will notice as Jenkins is building our project, It is also dynamically downloading the necessary software for each step. Okay, great. Now our build is done. Let's review the logs. Here we can see our main POM XML represented by the name Simple Multi-Module Build was successful, and our module Multi-3 was successful as well. Next, the archival of our artifacts was successful. Let's go to our Git source job and check out the workspace for our build. As we can see here, the artifacts from the last successful build have been generated and stored under last successful artifacts. You can see we have the multi-3-3.9-tetra var available here. That is the exact output with the proper naming convention we expected. Okay, excellent. Everything seems to be in order. Now we are ready to start creating our pipeline. Let's make a pipeline view for our project. We will name it var_tetra_noodle_deployment, and we will select this Build Pipeline View option. Then click OK to build our pipeline view. Let's skip most of these settings which are not essential and focus on the initial job setting. This is the job which will kick off the entire pipeline. We want our Git source job to be the first job in this pipeline. As such, we will select that as our initial job. We will also enable some other settings like Show Pipeline Project Headers, Show Pipeline Parameters Project Headers, Show Pipeline Parameters in Revision Box. The settings are pretty self-explanatory and are primarily used to output diagnostic information about the build. You can read about these options by clicking on the Help icon next to them on the right-hand side. Let's apply our changes to the pipeline and click OK. Here we are in our build pipeline view, but our pipeline contains only one project, which does not really provide us any opportunity to leverage the pipeline capabilities. We ought to create one or more projects which could be chained in this pipeline. So let's create a new project. Our Git source project was responsible for building our code and producing the artifacts. Now with our new job, let's make sure we deploy our application. We will call our new job var_deployment, and as usual pick Freestyle Project and then click OK. Okay guys, so this particular job will be responsible only for deployment. We do not need to worry about managing old builds. We don't even need to wire up the source control because this job will not interact with the source code at all. As a good practice, we should still enable this option to delete workspace before build starts to make sure we are always deploying the latest version of the deployment package. All we need is to configure this job to be able to copy artifacts from another job. And for that, we will need to install a new plugin called Copy Artifact Plugin. Let's install it now. We will save our Jenkins job for the time being, and we will click on the Jenkins logo to go to the Jenkins homepage. Then click on Manage Jenkins, and here click on Manage Plugins. We will navigate to the Available tab and search for Copy. Here it is, the Copy Artifact plugin. Let's select it and install it without restart. And allow Jenkins to download and install the necessary components for our plugin. Okay, great. The plugin has been installed successfully. After successfully installing our plugin, let's go back to our Jenkins homepage. Now we can continue to configure our job. Let's click on the var deployment job and click on the Configure menu. Scroll down to our Build Steps section. And in our build step, we now have a new step type, Copy Artifacts from Another Project. Once we select this option, we are presented with these configuration options for our target project. We will specify the source project name from where we need to copy the artifacts, exactly how we configured it. So we will type in git_source here. You will notice Jenkins is helping us out by auto-suggesting and completing as we type. For the target build, we will select latest successful build. There are various other options available for the target build, but we will keep it simple and just copy the artifacts for the previous successful build. Artifacts to copy. We can specify exactly which artifacts we intend to copy from our source project. If we do not specify anything, Jenkins will copy all the artifacts the previous project produces. Okay, let's save our configuration and click Apply again. Now we need to think about deployment. Once again, like most other features, deployment of the WAR file also needs a special plugin. So let's head to the Plugin Management Console and install this plugin called Deploy to Container. We will switch to the Available tab and search for this plugin. Here it is. Let's select it and install without restart. Okay, excellent. It has now been deployed successfully. After the plugin install is successful, we can go back to the top page. Now we can continue to configure our WAR deployment job. Click on the job title and now click on the Configure menu. Scroll down to Post Build Actions. You will notice that here a new option has become available called Deploy WAR to Container. Select this option for the post build action. And now we need to provide additional details to configure this action. First, we need to provide a pattern to look for the required WAR files, which we will be deploying to the target server. For now, let's use the most generic wildcard file path pattern, which will deploy all the files found in the target folder. For instance, if we were only interested in a particular file, say example.war, we could specify that path like so in this configuration setting. But for now, let's keep things simple and deploy everything. Next comes the context path. This is the path where our application will be deployed within our target servlet container. Please note that if you have a standalone version of Apache Tomcat deployed in your network or in the cloud, you may need to map the network DNS address of your Apache Tomcat server by modifying the host file both on our Windows host machine and also your Jenkins CentOS instance. Let's do that now for our instance. We will open the host file on our Jenkins host using the VI editor. Now let's grab the IP address and hostname of our Apache Tomcat server and update the host file with the mapping. Let's also add the HTTP mapping to make sure Jenkins can successfully connect our Apache Tomcat server. Great! Save this file and quit the editor. Now our Jenkins instance will be able to resolve the DNS name for our Tomcat server and access it without any problems. Let's continue with our job configuration. Coming back to our context path, this is the exact name and path Apache Tomcat will use to deploy your app. In continuous integration and continuous delivery scenarios, sometimes we can use a special pattern for our context path. For instance, we can use this context path, tetra_noodle_up_ $build number. Basically, this will pull the actual build number of our current build and append to the context path. We can use other environment or Jenkins provided variables here as well. If you want to get a quick glance at all the possible variables you can use, click a build action of execute shell and down below click on this link, the list of available environment variables. Here is a page with documentation about all the variables available to us within our Jenkins jobs. You can read about them and use them whenever you want. Coming back to our job, this pattern will allow us to push a fresh deployment every time a change is made with the build number for the current job. For the post-build action deploy WAR, we also need to configure a container. For our container, we have Tomcat version 7, and we have configured a standard username and a standard password for our Tomcat server. We will specify those credentials right here. We must emphasize here that using the admin user is only for convenience purposes, and it is not recommended for production environments. You must ensure that you have a user with appropriate and minimal required permissions set up for these integration scenarios. Finally, we will add the Apache Tomcat URL. We will simply copy it from our browser window and paste it right here. Great! Now our job is ready. We can click Apply and save our job. Now, the next step is to chain up our projects in the pipeline. So, for that, we will get back to the configuration area of our job by clicking on the Configure link. Here we will scroll down to the Build Trigger section and select this option called Build After Other Projects Are Built. And for projects to watch, we will select our Git source job. This will trigger the deployment job after this Git source job has completed successfully. Thus, this configuration is now taking a shape of a chain of jobs or pipeline. In fact, there is another way we can configure these pipelines. Rather than watching for other jobs to complete and use that event as a trigger, we can configure a post-build action on the source job to execute the target jobs. Let's try it out. We will navigate to our job's home and click on Git Source Job. Here on the configuration screen, we will scroll down to Post Build Action. We will select this Build Other Projects and select the target job. For instance, we can select to trigger WAR Deployment Project. The end result is exactly the same, and the two approaches are merely a difference in semantics. Let's click Apply and save our job. Next, let's go to our Build Pipeline view and start our pipeline. Let's enable auto refresh so we can review the pipeline execution in real time. So our Git source job has started and it's in the process of building our source. Now after Git source job has completed successfully, WAR deployment has started. Okay, WAR deployment step has failed as signified by the red background for the step. I think we ran into the most common issue we run into while deploying apps in Tomcat. The user we configured in our Jenkins job did not have the right permissions to deploy the app into the container. Let's go ahead and fix that. We will go to our Apache Tomcat server session and edit the Tomcat user's XML file. And here's our admin user. We need to make sure that our user has all these admin level permissions and roles. For instance, admin GUI, admin script, manage JMX, manage status, etc. We have already fixed the issue for this user, so let's go back to our pipeline now and try to run it again. Okay, after our Git source job completed successfully, we can see the next deployment job has been kicked off. Let's wait for it to finish. Okay, great. As you can see here, WAR deployment was successful as well. Let's check out the console output by clicking on this tiny console icon. As you can see here in the console output, the deployment of our app was also successful, so everything looks good here. Now, navigate to the Apache Tomcat Application Management Console and click on the Manager App button to navigate to Tomcat Web Application Manager. Here you can see our newly deployed app is available with the name tetra_noodle_app_4. Here 4 represents the build number, which has been assigned by our Jenkins job. Click on our web application and browse. Here is the home page for our simple app. Welcome to Tetra Noodle Training Site. This is the home page for the Tetra Noodle CI-CD training. This verifies that our first web Java application was successfully deployed with Jenkins CI-CD pipeline. Let's recap what you learned in this module. First, we implemented a Jenkins job for our Java web application project. Next, we installed and configured several plugins for Jenkins like copy artifacts, deploy WAR plugins, etc. to get Jenkins ready for our end-to-end CI and CD pipeline. Then we updated our Jenkins jobs and integrated them with the help of various plugins. Last but not least, we ran our job and deployed the build artifacts from our Jenkins server into our Apache Tomcat container. Stay tuned for the next module, where we will learn about an excellent database schema management tool called Skitch. Hello, and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we built a CI and CD pipeline for a Java web application project using Jenkins, Maven, and Apache Tomcat. In this module, you will get familiar with another important tool to manage our relational database schema versioning. This tool is called Skitch. So let's get started. Any modern application needs to save and read data from a persistent medium. More often than not, this persistent medium is a relational database like MySQL, PostgreSQL, etc. These databases have been around for decades, but deploying and updating our databases in a consistent manner is not an easy task. In this module, we will try to solve this problem and guide you through the process of creating a CI-CD pipeline for database deployment. First, let's start with a review of our environment. Our database source code will be written as Sql Script Files and be stored in Git. We are using a Git repository hosted within Bitbucket. Our database platform of choice will be PostgreSQL. Here is a free and open source administration tool called PHP PG Admin, which we will use to manage our relational database. The idea here is that we will submit all our schema and source code changes from our database to our Git repository. Then we will create a Jenkins job to pull the latest source from our database Git repository and update our database with the changes in a consistent manner. It may sound like a very simple and straightforward task, but anyone who's been in the software development and DevOps field for some amount of time will attest to the fact that managing source code for database changes and applying them consistently across multiple environments is very hard to do. For managing the schema of our relational databases in a consistent manner, we will use a popular versioning and source control management tool called Skitch. Skitch is a database change management framework which can help us manage our database changes in a consistent manner. It supports scenarios where multiple developers on the development team are checking in changes simultaneously in an agile fashion. Skitch keeps track of all these changes and is able to apply them to target database environments. Skitch supports various database engines like PostgreSQL, SQLite, Oracle, MySQL, etc. The actual usage of Skitch is very similar to working with a regular database management tool like Git or Subversion. Here are some of the core commands which Skitch supports. Skitch init project name. This initializes a Skitch project and the required files and directory structure for our Skitch project. Each Skitch project consists of the following files and folders. Skitch.conf. This is the configuration file for the project and contains settings like information about the target database, etc. Skitch.plan. This file keeps track of all the changes and respective sequence of the database's changes. Deploy. This folder contains SQL scripts which will deploy the changes to the target database. Revert. This folder contains SQL scripts which will revert the changes in case of any errors or issues. Verify. This folder contains SQL scripts which will verify whether the applied changes were deployed successfully or not. In order to create a database change in a project, we can use the command skitch add change name, and Skitch will initialize boilerplate SQL scripts in the respective folders. It will also update the plan file with the new change. Once created, the developers are responsible for adding detailed code changes to the boilerplate files and ultimately pushing all these changes to the source control repository. That was a quick overview of Skitch. To download the latest version of Skitch, you can go to http://skitch.org. You can also install Skitch via Linux package managers. We have already installed Skitch on our system and initialized this project called db_test. Let's review the code for our project now. Here's our skitch.conf file. Skitch supports a number of options and settings in this file, but as you can see, most of the options are commented out using the hash symbol. This is very similar to Bash file format. These settings which have been commented out will be assigned the default values by the Skitch engine. So Skitch makes it quite easy for us to get started. The setting which is available is engine, and the value for this is PG. This signifies that Skitch should be able to use PostgreSQL as the relational database engine. The next important file is the skitch.plan. This plan file tells Skitch engine about what commits have been made into our Skitch project repository, their respective sequence, dependencies between the commits, etc. For instance, we see here there are 2 commits in the order listed here in the plan. So let's keep these commits and the sequence in mind. First schema, and then video. Now let's review some SQL script files. In our deploy folder, we have 2 files right now, schema.sql and video.sql. Let's review the code in schema.sql. We can see this code creates a schema called tutorial in our PostgreSQL database. In video.sql, we can see this script creates a table called tutorial.video with 3 columns. Subject, which is a string-based column and is the primary key, comment, and timestamp. Basically, when we run Skitch to deploy the project, it will look up the plan as per the sequence. First it will run the schema commit, and then the video commit. In other words, this project will create a schema called tutorial, and then it will create a table called video in that schema. So you see, Skitch manages all the complexity in a rather simple manner. And in doing so, it provides very familiar processes and paradigms to developers to manage their databases. Skitch not only allows us to deploy our changes, but it also has inbuilt mechanisms to verify and revert the changes in case something goes wrong. This happens via the scripts in revert and verify folders. Let's review them now. In this revert folder, we will see there are corresponding revert scripts to each commit in our Skitch plan, that is, schema and video. This schema revert file will simply drop the schema our deploy script may create in the target database. Similarly, in video.sql, it will drop the table tutorial which may have been created by the deploy video.sql script. Now let's move on to the verify scripts. What you can see here is a very clever way to verify the existence of schema. We are selecting the count of schemas named tutorial and dividing 1 with that number. If the schema exists, this count function will simply return an answer of 1, which will be divided by 1. Hence, the script should yield the final result of 1 divided by 1. But if the schema does not exist, the count will return 0. And attempting to divide 1 by 0, it will cause a divide by 0 error. Thus, this verify script will flag the problem in an elegant manner. Similarly for our video table, we are executing an SQL script to select all the columns from our video table, but notice here the where clause is false. Basically, here we do not intend to read any data from the table whatsoever. but we want PostgreSQL to verify the existence of this table and make sure all these columns exist. If the table does not exist in the database or the table structure does not match the expected structure, then Postgres will raise an error and thus will serve the purpose of verification of this commit. So when our team, or any other team, works on the same database at the same time, they just need to add their comments to the Skitch repository using the Skitch commands. Skitch will ensure everything is kept track of and managed well. In fact, many of the Skitch commands are very similar to Git, so developers who are familiar with Git will feel right at home with Skitch. Okay, after this whirlwind tour of Skitch, let's switch back to Jenkins and start working on our CI-CD pipeline for our database. Let's move on to our Jenkins homepage. Here we will create a new item or new job for our CI-CD pipeline process. Let's name it db_source, and as usual, pick Freestyle Project for the project type, and click OK. Let's take care of the housekeeping first. We will keep the builds only for 4 days and keep the last 4 builds. Next comes our source code management. We will wire up our public Git repository here. We will get the URL from our Bitbucket repo from the overview section. Copy the URL and paste it in our Jenkins Job definition. Let's also check delete workspace before build starts to ensure we have clean and consistent builds. Now let's configure build triggers for our job. This time, let's pick poll SCM so that Jenkins can watch our Git repo and trigger a new build when changes are pushed to the Git repo by our development team. This polling is implemented in a similar way as a cron job with Jenkins, such that after regular intervals, our Jenkins job will ask our Bitbucket repo, "Hey Git, are there any new source code changes available or not?" We are going to specify this cron type expression to check the SCM every 5 minutes. And if there are, our Jenkins will trigger a build for this project. But if it does not find any fresh commits, Jenkins will simply wait for the next interval before checking the SCM again. Now we need to start configuring the meat of our job, which are the build steps. This is the most important part of configuring our job. For this particular job, all we need is to execute a shell command. Unfortunately, there is no special plugin for Jenkins to use Skitch. Not yet, anyway. Jenkins has a huge community of developers and enthusiasts supporting it and writing awesome plugins for it. It is just a matter of time before someone comes up with a kick-ass plugin for a kick-ass tool like Skitch. If it strikes your interest, we encourage you to develop it and contribute back to the community. Anyway, the lack of plugin does not hinder us in the least. Since Skitch can be executed from the command line, we can easily integrate it into our job using the shell command step. Let's keep in mind that when we use execute shell build step, this build step will be executed on our server as is, just as if we were executing the command on the native shell on our Jenkins machine. So in order to make sure that our shell command step can find the required commands and files for Skitch, first we will change the current directory to the Workspace directory. Notice this is an environment variable with a $sign. As we've reviewed earlier, Jenkins provides access to multiple environment variables which could be used anywhere within our job definition. We can click on this handy link to view the list of available variables. This is Workspace environment variable. It gives us the full path of the Workspace directory at runtime. And now let's review what a Workspace is. For each job on Jenkins, Jenkins allocates a unique Workspace directory. This is the directory where the code is checked out and builds activities take place. In most cases, we should let Jenkins manage this directory and its contents. But as we have seen in various job definitions that we created, it is a good practice to select an option to delete this Workspace directory before a new build is triggered. This will ensure that the current build is clean and the files and artifacts from the previous build do not interfere with the current build. Since the Workspace directory is where all the code will be copied to once our Jenkins job pulls it from our Git repo, we must switch to that directory while executing our shell commands. So let's add that as the first line in our shell script. cd $workspace. Next, we will execute our skitch command via shell command. The exact command is skitch deploy db :pg :deploy at 192.168.0.103:5432 Let's review that command in detail. We are using the deploy option to run our skitch tool because we intend to deploy the database scripts to our database. Next, we are specifying that our database engine is going to be PostgreSQL. Next, we have our user information and the credentials needed for the user who has access to the database. Next is the IP and port of our database server. And finally, we have the database name. Please note that all this configuration could have been provided in skitch.cnf as well, but we are using a command line parameter option to explicitly demonstrate how Skitch wires everything together. Basically, we are running the deploy command for Skitch and supplying the information about our target database. Skitch will look for the plan and the commits in our Skitch project. It will also query the current state of the database and determine whether there are any Delta scripts which need to be applied to the target database. If so, Skitch will use the specific scripts from the deploy folder which match the Delta commits. And ultimately, Skitch will run those scripts against the target database, bring the database at par with the current project commits, and save the versioning information in the database itself. Please note that while running the skitch command, we are using a PostgreSQL user who has the necessary privileges to create, update, delete database objects like tables, schemas, etc. Alright, our job configuration is done for now. Let's click Apply and save our job. We won't run this job yet because we also want to create a Jenkins pipeline for verification of our schema changes. We do need the Build Pipeline plugin before we can build our pipeline, so let's make sure it is installed. We will click on Manage Jenkins, then click on Manage Plugins, and then click on Available tab. We will search for Build Pipeline. Here is our Build Pipeline plugin. We will select it and install it without restart. Now Jenkins will automatically download the plugin and necessary dependencies and install our plugin. Okay, now our installation has completed successfully. Let's click on this Go Back to the Top Page link to get back to the Jenkins homepage. And now we can create our build pipeline view. We will click on this plus icon, and for our pipeline view, we will use the name db_tetranoodle. Click OK. Here let's configure the most important setting, which is the initial job, which will kick off this pipeline. In our case, that is the db_source job, which will actually deploy the changes to our database. We will also check some options to make our pipeline more informative. And now click on Apply and then OK. Here we are in our build pipeline. So why did we opt to create a build pipeline here? Because Skitch allows us to verify the status of our database deployment. Once the database deployment executes via this build job, if there are any errors or issues detected, we can execute the revert command for Skitch to roll back all the changes which were just applied to our database. Thus, this will ensure our database is always in a consistent state. To complete those steps for our pipeline, we will create a new job. This new job will be almost identical to the db_source job. We will call this new job db_verify. This new job will be pretty much identical to our db_source job. We will connect this job to our Bitbucket repository. and then add a similar shell command to execute our required commands. First, we will change the current directory to the Workspace directory, and then add the skitch command. Here we will use the verify option for skitch to verify our deployment. As this verify command executes, skitch will execute the verify scripts from our skitch project and look for any errors. Now let's save this job. And next, let's make this job a part of the pipeline. We will go back to the configuration screen from our db_source job and scroll down to post build actions. Here we will pick Build Other Projects and select db_verify project to wire it up in the pipeline. Let's save and get back to our pipeline view. In order to monitor the state of the schema and database, we have this PostgreSQL management tool called php-pgadmin. We've already connected this to our target database tetranoodle. As we run our jobs, we will see what changes are applied to our database. We can see here, the only schema available in our current database is the default public schema. Now we will run our pipeline and observe how Skitch works its magic and updates our database. Let's click on the Run icon to run our pipeline. Our first job, db_source, is running now. Behind the scenes, it is connecting to our database and running all the required scripts against it. Okay, great. Our first job has finished successfully. And now it has kicked off the second verify job. Excellent! The second job also completed successfully. We will disable auto refresh and head to our php-pgadmin tool to review the database updates. We will refresh the schema by clicking on this refresh icon. As we can see in our database, a new schema has appeared called tutorial. Under this tutorial schema, we also have a new table called video. This video table structure matches exactly what we expected after applying the deployment SQL script from our source repository. As you can see, Skitch and Jenkins made it pretty easy to build a sophisticated build and deployment pipeline for our relational databases. We can configure our Jenkins jobs to monitor our source control system and look for any new database changes coming from various team members. From there, Jenkins can apply the changes to our integration, staging, or production database environments. These pipelines can be integrated with other build and deployment pipelines which deploy the latest web application code, middle-tier code, and ensure that all layers of the system are in sync. The possibilities are endless here. Let's get back to our pipeline and review what happened. So we already saw both our jobs succeeded. Now let's check out the console output for our verification job by clicking on this console icon. Here is the latest commit information as well, and here we see the job completed successfully. So the first job ran the deploy command, and then this job ran skitch verify against our target database with the correct skitch project name. Before we wrap up this module on deploying database changes, let's discuss some environmental challenges you may face while using these tools together. One issue you may run into is that PostgreSQL may not allow your Jenkins machine to connect to the database, especially if they are deployed on separate machines, physical or virtual. By default, PostgreSQL is a secure database, and its default behavior is to listen for TCP IP connections only on the local loopback address localhost. So, to get around this problem, we will need to let Postgres allow connections from our Jenkins machine. To do that, we need to update the client authentication for our Postgres server. Client authentication is controlled by a configuration file, which traditionally is named pg_hba.conf and is stored in the database cluster's data directory. HBA stands for host-based authentication. So we will log on to our Postgres server and edit this file. And we will make sure that our trusted hosts are allowed connections to our database server. We can either use the host name or the IP address of our host machine to configure it as a trusted host. We can use either IPv4 or IPv6 IP addresses here. More detailed documentation about this file can be found online within the Postgres documentation archive. After we modify this file and allow the required connections, we will save this file and exit. Please do remember to restart your database server for these settings to take effect. The next issue you may encounter is your firewall or on a Linux system, a security module like SE Linux. To enable connections from our Jenkins machine, you will need to configure appropriate IP and ports to be allowed the connection. Once again, for convenience, in our case we have simply disabled our firewall by editing this file, /etc/sysconfig/SE Linux. Here we have changed the SE Linux to disabled and SE Linux type to targeted. This will be enough for you to disable your firewall, and it may really end up saving you some time while trying to connect to your database server. Once again, this quick security configuration is only for testing and demo purposes. Please do not follow these conventions for production environments and consult a security expert for proper configuration of your servers. We also suggest that you install php-pg-admin on your database server. It is a pretty simple and easy to use web-based administration tool. You can get more information about this handy tool from their website, http://php-pg-admin.sourceforge.net. You can also install phpg-admin using yum install. Please do not forget to install the HTTPD service as well, because php-pg-admin is a web-based tool. After installing the tool, you can access it via your web browser, just like any other web application. Let's recap what you learned in this module. First, you got an introduction to Skitch framework. Next, we built a Jenkins job and updated our database schema using this Jenkins job. After that, we also discussed some tips and tricks which we need to keep in mind while working with relational databases in a DevOps environment. Stay tuned for the next module where you will learn about some operational and administration aspects of Jenkins. Hello, and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we built a CI and CD pipeline for a relational database project using Jenkins and Skitch. In this module, we will talk about some operational considerations you need to keep in mind when deploying and maintaining a production-level Jenkins cluster in real-life projects. In this module, you will learn about securing the Jenkins instance and also scaling the Jenkins infrastructure by installing multiple nodes. So let's get started. We will begin the discussion with configuration of security for our Jenkins server. Why should we start with a discussion on security? Because security has implications on the subsequent discussions about scaling the Jenkins infrastructure to multi-node clusters. So understanding the security configuration will help us later when we install Jenkins slaves and connect them to our Jenkins master server. Let's get started with securing our Jenkins server. Click on the Manage Jenkins menu on the left-hand side, and on this Manage Jenkins page, click on Configure Global Security. One of the first options we see is to be able to configure our TCP port for JNLP agents. This is the TCP port on which our master Jenkins server will allow the slaves to connect via Java-based technology called JNLP. JNLP stands for Java Network Launch Protocol, and it enables an application to be launched on a client by using resources that are hosted on a remote web server. These JNLP port settings play a critical role when connecting slaves to the master Jenkins server. So let's configure this first. By default, this port is disabled, but to enable it, we have two options. We can either set it to a fixed port or a random port. Under fixed option, we will need to provide a specific port for these connections. This option may be better if you are behind a complex corporate network and you have to configure firewalls between master and slave nodes. But for usual setups where all master and slave nodes are in the same network, random port is recommended. Here, Jenkins will pick an available port automatically. So we will pick the random option here and move ahead. Next, we come to the access control section. This section controls the core of the security and permission settings. When users log on to Jenkins UI, they are authenticated and an appropriate set of permissions are assigned to them based on these settings. The security setting within Jenkins is controlled mainly by two axes. Security realm, which determines users and their passwords, as well as what groups the users belong to. Authorization strategy, which determines who has access to what. These two axes are orthogonal and need to be individually configured. For example, you might choose to use an external LDAP server like Active Directory as the security realm, and you might choose everyone full access once logged on mode for authorization strategy. Or you might choose to let Jenkins run its own user database and perform access control based on the permission user matrix. Here are the configuration sections where you can configure both these security axes. By the way, please do remember that for each of these options, there is a handy tooltip available with detailed documentation. All you have to do is click on this question mark icon and the helpful tip will pop up. Delegate to server container. This option is only applicable to older versions of Jenkins. For Jenkins version 2.0 and above, this option is not applicable. This next option is to use Jenkins' internal database to store the user information. Using this option, we can also select this option to allow users to sign up for a Jenkins account. Although, this option should only be turned on with extreme caution. Next is LDAP. LDAP stands for Lightweight Directory Access Protocol. It is an application protocol that is used over an IP network to manage and access a distributed directory information service. The primary purpose of a directory service is to provide a systematic set of records, usually organized in a hierarchical structure. Windows Active Directory is one example of an LDAP directory. So basically, this option allows us to secure Jenkins based on corporate network credentials. Unix User Group Database. This is similar to Jenkins User Database, but instead of using the internal database, this option will use Linux or Unix users and groups for authentication of the users. Unless you have any specific requirements, in most cases using the option of Jenkins' own user database will be sufficient. Moving on to authorization. The first option of anyone can do anything is the most liberal option, but it is the most insecure. This allows for anonymous users to pretty much take control of the Jenkins server and make any kind of changes. So it is not recommended that we select this option, especially in production environments. Moreover, since Jenkins server is secure by default, if we select this option, Jenkins will lock down some necessary functions. For instance, it will not allow us to manage user credentials or allow new users to sign up. The next mode is the legacy mode, which means that only administration users can manage and make configuration changes with Jenkins. Basically, under this mode, all non-admin users can read Jenkins configuration, but not change it in any way. In some situations, this option can be very useful. What is logged in users can do anything? This is similar to the first option, anyone can do anything, but the difference here is that Jenkins forces the users to log in. Once they are logged in, they basically have administrator privileges. Just like anyone can do anything option, this option is not recommended either. This is because giving too many privileges to users may potentially break the CI-CD process because these users may make mistakes or break the process maliciously. Furthermore, this option can also allow anonymous users to view Jenkins in a read-only mode. The most useful and frequently used options are matrix-based security and project-based matrix authorization strategy. They are very similar in the functionality they provide. The most significant difference between them is that matrix-based security is for entire Jenkins infrastructure, while project-based matrix authorization strategy can allow you to manage security access for specific projects. The latter could be quite useful if you have numerous subteams who are sharing a common Jenkins infrastructure. In that situation, specific projects can be assigned to specific subteams, and they can all share the Jenkins instance without stepping on each other's toes. For a small-scale cluster, matrix-based security is a good option. Let's see how we can configure it. Let us start with some users here. If you don't have any users within your Jenkins instance, you can configure them under the Global Security Management section. Anyway, let's add the required users here and configure their permissions. Say we add the root user. If this is a known user to Jenkins, then this root will be represented by this little blue icon. This means root user already exists in our Jenkins user database. Let's try to add a new user to Jenkins. Name this user Deploy. And now you will notice that the user icon has a little red X on it, which signifies that there is no such user in our database and Jenkins does not recognize it. Before we can log in as this user, we will need to create it. Let's delete this deploy user for now, and let's give our root user all the necessary privileges. One important thing to keep in mind while using this matrix-based security settings is that you must assign this overall read permission to every new user that we want to be able to use Jenkins. Without assigning this permission, our users wouldn't be able to access the system at all, and they will be locked out. So this option is essential. As you can see, this matrix-based security settings allow us to assign fine-grained permission control to our users and user groups, like permissions to manage credentials, permissions to manage agents, manage jobs, etc. Not only that, even the plugins we install could have specific permissions controlled within Jenkins. For instance, we can assign permissions for specific users to manage Artifactory. Alright. Now our root user has all the permissions to do pretty much anything with Jenkins. Let's click Apply and save our configuration. Now let's go ahead and create some new users. We will click on Manage Jenkins and then click on Manage Users. Here we can click on User menu on the left-hand side and create a new user. For example, let's create a user called test1 with password test, full name of test, and email address of test@tetranoodle. This new test1 user has no privileges within Jenkins. This means this test1 user will not be able to access Jenkins or make any modifications to it. To configure security for this particular user, we can click on Manage Jenkins again, and then Configure Global Security. Here under the matrix-based security option, we can add our new user and configure necessary permissions as needed. For now, let's just give an overall read-only permission to this new user and click Apply and Save. In the previous lecture, we configured Jenkins security. In the process, we created a new user and configured fine-grained permission for our users. After configuring the security of our Jenkins instance, we are now ready to scale our system by adding slave nodes to our infrastructure. Now let's go through the process of adding Jenkins nodes to our Jenkins cluster and scaling our Jenkins infrastructure. Jenkins supports a scalable master-slave architecture, where the workload of building projects can be delegated to multiple slave nodes. This scalable master-slave architecture allows a single Jenkins installation to host a large number of projects, or to provide different environments needed for builds and tests. A master, operating by itself, is the most basic installation of Jenkins, and in this configuration, the master handles all tasks for your build system. If you start to use Jenkins for increased load for multiple projects, with just a single master server, you will most likely find that you will run out of resources, memory, CPU, etc. At this point, you can either upgrade your master server or move it to a more powerful machine. Or, you can set up slaves and scale horizontally. In this mode, the additional slave nodes will pick up the load. As mentioned earlier, you might also need several different environments to test your builds. In this case, using a slave to represent each of your required environments is almost a must. For instance, you may have several projects, some of which need Linux operating system for testing, and others may need Windows operating system. For this setup, it will be essential to install Linux and Windows slave nodes. Of course, one of these required hosts could be a master. A slave is a computer that is set up to offload build projects from the master, and once set up, this distribution of tasks is fairly automatic. The exact delegation behavior depends on the configuration of each project. Some projects may choose to stick to a particular machine for a build, while others may choose to roam freely between slaves. There are various ways to start slave agents, but in the end, the slave agent and Jenkins master need to establish a bidirectional communication link, for example, a TCP/IP socket, in order to operate. Alright, after that brief overview, let's go through the process of creating our Jenkins slave and connecting them to our master. Let's refresh our memory about our environment here. Our host operating system is a Windows machine, and our Jenkins server is running within a CentOS virtual machine hosted within a virtual box on our Windows host. For our cluster setup, we will install a Jenkins slave agent on our Windows host machine and connect it to the master server running within our CentOS virtual machine. So basically, we will install the Jenkins server on the host machine and configure it as an agent. To get started with the installation, we will go to the official Jenkins website and go to the Download Jenkins page. We will download the Windows installation package for Jenkins from here. Let's wait for the download to finish. Alright, now that we have the installation package downloaded, all we need to do is run it. We will go through the installation wizard and accept all the default values to install Jenkins on our Windows host machine. Let's wait for the install to finish. Okay, click Finish to complete our installation. Now we have a full-fledged instance of Jenkins running on our Windows host. We can access our Jenkins instance by navigating to localhost, port 8080 in our browser. The actual process of initial configuration for Jenkins is almost the same as in Linux. The only difference is where to get the initial administrator password from. On Windows-based systems, the password can be found under Program Files /Jenkins/secrets/initial admin password. Let's go find this file and get our initial password. We will navigate into the secrets directory and open the initial admin password file with Notepad. Here is the password. Let's copy it and paste it into our configuration window right here. So as we said, the rest of the process is pretty similar to the one we walked through earlier. We will install the suggested plugins and accept defaults. If we need some additional plugins in the future, we will search and install them later as needed. Installing too many plugins ahead of time may also cause various issues like performance issues, misconfiguration, and security-related issues. We've encountered in some situations where in big projects, Jenkins had too many plugins, and after running the system for a period, things got so convoluted and unwieldy that it becomes hard to trace which plugin is doing the necessary steps. Anyway, after our configuration has completed, let's create our first admin user. We will keep things consistent and use the same root user here as on our Windows instance. Username is root with a password. The full name will be Tetra Noodle with an email address of tetranoodle@root. Now let's click Save and Finish. Great! Our initial configuration is all done. Now let's start using Jenkins. Okay, here we are on our Jenkins homepage. You can see the interface is identical to our Linux instance. So just to recap here, we are working with two Jenkins instances now. We have opened the homepage for our two separate Jenkins instances in two separate tabs of the browser. One is the local host instance, and the second one is our CentOS virtual machine instance. Here is the localhost instance, and here is the jenkins.noodle.tetra instance, which is our CentOS instance. Now let's go ahead and connect our slave with our server. On our CentOS server, we will click Manage Jenkins, and then click on Manage Nodes. This page lists all the nodes which are connected to this master. As we can see right now, we only have a standalone server, so we only have one master server listed here. To add a new slave node, let's click on the New Node menu. Let's name our node Windows OS and select this permanent agent option. This is permanent because Jenkins does not provide any dynamic provisioning. Basically, once the Jenkins instance assumes a slave role, then it will be permanently connected to the master as a slave. We will click OK to proceed with the configuration of our new node. Here, description for this node is optional. The maximum number of Jenkins jobs is dependent upon what you set as the limits in the master and slaves. Usually, we specify this limit based on the number of CPU cores in your slave machine. But your mileage may vary depending upon available memory, disk space, availability of SSD, and overlap of source code. The limit is controlled by this setting, number of executors. For our new slave, we will set it to 2. The remote root directory is mandatory, and we need to specify the path to our Java home directory here. Please note the path is the actual path on the slave machine. Next is our usage setting. We can set our slave to be used to its maximum capacity and at the discretion of the master. Alternatively, we can be more selective and assign it only particular builds. For instance, say some components may need a test framework to run test builds, so we can assign it dedicated servers where this testing framework is installed. Here we select Use this node as much as possible and Launch agent via Java Web Start. Let's check Advanced button, which will enable us to specify some additional options like JVM custom options. But for now, we will accept the default values for the rest of the settings and click Save to save our node configuration. Okay, great. Now we see a new node defined in our list of nodes. Now, since we have configured our network such that both our host and the virtual machine can connect to each other, it is rather straightforward to connect these two Jenkins instances together. In your own environment, please make sure you are on the slave node with a browser instance launched on the local slave node. And from there, you navigate to the Jenkins master server homepage for this connection to go through as smoothly as possible. We will click on our Windows OS instance to get the details page for our new node. And click on Launch button to launch the agent from our browser window. One word of caution here. Sometimes the JNLP launch may not work due to some misconfiguration. In that case, it is helpful to run this batch command to troubleshoot that problem. Anyway, let's click on the Launch button and wait for the agent to launch. Upon clicking this button, it has downloaded an installation file with the extension of JNLP. Let's run this file to launch the agent. This JNLP file is called a Java Web Start file, which allows you to download and run Java applications from the web. If you see any warnings or prompts to proceed with running this application, please agree to those and click on Run to launch our agent. Looks like our agent has started and connected successfully to our master. Once it is connected, we can go to the Jenkins homepage for our master Jenkins server, and we will see 2 new executors have been added to our cluster on the Windows OS node. Our main CentOS instance is master, and our Windows node is connected as slave. We have a total of 4 executors, and all of them are idle right now. Okay. Now let's change the configuration of our cluster such that all new jobs are assigned to our slave node on a preferential basis. We will click on Manage Jenkins on our master server. Click on Manage Nodes, and we will click on Master Node to make the necessary configuration changes. Here we will click on the Configure menu on the left-hand side. Under the Usage setting, we will change it from the default value of Use as much as possible to only build jobs with label expressions matching this node, and click Save. With this change, any new job which is queued will only run on the master node if it matches certain conditions. Since we specified usage of use as much as possible on our slave node, most if not all of the build jobs will be assigned to our slave node. Now let's go to our Jenkins homepage. Let's create a simple job to verify our slave and master connectivity. All this job will do is execute a Windows batch command. We are going to use Windows batch command instead of shell command because this job will execute on our Windows node. For the actual command, all it will do is print a phrase on the command line, Tetranoodle tutorials. We will specify this by using the echo command. Okay, there we go. Let's click on Apply and Save. Let's run this job and observe how this job gets executed. As we can see, our job built successfully, and it was executed on Windows. Jenkins is a highly scalable framework and is perfectly suitable and capable of handling tens of hundreds or even thousands of builds simultaneously. It is suitable for distributed and large teams and subteams. It has all the features to securely run the complex build systems in a highly dynamic environment. Not only that, Jenkins supports a plethora of technologies, languages, frameworks like Java, JavaScript, Ruby, C#, Golang, etc. To scale to these highly concurrent and demanding levels of efficiency, we need to build scalable and distributed clusters of Jenkins nodes. Even with memory getting relatively cheap and multiple core CPUs becoming commonplace, running such a large system on a single Jenkins machine will be almost impossible or prohibitively expensive. So we must think about scaling out with the user of master-slave architecture, which is supported by Jenkins out of the box. Now in this session, we will discuss some tips and tricks that you should keep in mind about setting up these highly scalable clusters of Jenkins infrastructure. First, let's discuss the master node. As mentioned earlier, the master Jenkins server is the central controller node which coordinates and assigns build jobs across the cluster of nodes. So it is very important that we keep the master Jenkins node very responsive, especially since most people accessing Jenkins will do so via the web interface, which is running on the master node. Try to remember that running and managing build jobs is a demanding task and requires a lot of memory and CPU resources, so it is advisable not to run any jobs on the master node. If you are involved in large projects, and if you choose to run your jobs on the master node, you may run into situations where the master node is overwhelmed while running the build jobs and has no resources left for running the web interface or managing other aspects of the Jenkins cluster. As such, the master node may become unresponsive, or worse, the cluster may suffer an outage. Furthermore, to protect against these disastrous scenarios, don't forget to make regular backup configurations for your Jenkins master node's configuration. Now moving on to the slave nodes. First of all, the slave node should be quick to set up and throw away if they suffer any type of software or hardware issues. Plan your slave server for high usage and optimal efficiency. It should be utilized to the maximum capacity, and you should run multiple jobs on it, not just a single job. Always plan the slave node's hardware for really high usage. Regularly and diligently monitor your CPU and disk usage over the slave nodes. It is also a good idea to segregate heavy and more complex jobs to a separate set of beefy servers, so they do not end up blocking the smaller and quicker jobs in the queue. In case any of these jobs are too demanding, it is even advisable to isolate them and assign them to dedicated slave nodes, so that they do not end up affecting the efficiency of the entire build queue. That is how you will avoid all problems with accidentally failed jobs. Another good practice is to pick your plugins for Jenkins responsibly. Once installed, please ensure they are configured properly, and you regularly update their versions. Moreover, please also take care to clean up unnecessary plugins. These unnecessary plugins may end up cluttering the whole system and may cause unforeseen issues. Another good practice is to install and configure logging and monitoring for your Jenkins nodes themselves, so that you can easily and quickly troubleshoot the problems when they arise. Another good practice about build jobs configuration is to keep the logic for the build job simple and straightforward. Try to avoid too many steps in a single job. If you do need multiple steps, it may sometimes be easier to break them into logical groups and configure them as separate jobs which are chained together. This achieves the same purpose, but the build configuration is much easier to maintain when they are of manageable size. Avoid using any complex logic in your shell command steps. We use shell commands in our course because most of the jobs needed very straightforward shell commands without any direct rules embedded in them. As the complexity of the jobs grow, using too many shell steps just multiplies that complexity exponentially. Another usual problem you may run into is source code management and its integration with Jenkins. It is always a good practice to manually pull the source code on the Jenkins node and verify whether Jenkins can access the source code directly or not. You can even take it one step further and run the entire build manually on the node before automating it with Jenkins. What are some concerns about archiving your artifacts in Jenkins? Jenkins is not optimal at this at all. This is why we suggest you use a repository manager like Artifactory for storage and management of your build artifacts. These solutions are much more robust and easier to manage than vanilla Jenkins. Moreover, most of these repository manager solutions work really well with Jenkins in most cases with the help of plugins. Let's recap. First, you got an overview of Jenkins security functionality and how to secure Jenkins. Next, you learned how to scale your Jenkins cluster by adding additional agent nodes to your cluster. After that, we also discussed some tips and tricks which we need to keep in mind while deploying and managing Jenkins cluster. This wraps up this course on continuous integration and continuous delivery with Jenkins pipelines. In this course, you got familiar with DevOps concepts and Jenkins in particular. You learned about essential components of the Jenkins setup. We hope you had as much fun learning about Jenkins as we had putting together this course for you. Let's stay in touch. You can also connect with us directly via LinkedIn, Twitter, or email. We will be glad to help you out in any way we can. Please do not forget to leave a review of this course. It will really help out me and other learners. And last but not least, please do check out the other top-rated courses we are offering. There are many special offers available for you in the last bonus lecture of this course. Please consider it our token of appreciation for our current students.